Solid Skins V1. I'm very excited to have this webinar. It's going to be using Rhino, Blender, and Unreal. We're here with Gediminas, and we're going to it's hard for me to get my brain to do that. I'll introduce him and we'll go on. So Gediminas is an architect and a lecturer based in Sweden. He works as a course coordinator for architecture department of Lund University, runs 2 competition design oriented channels on YouTube, and is also a co-founder of Very Good Architecture Company, Lithuania. His current work and research revolves around real-time environment generation and manipulation techniques, where he's investigating how new emerging technologies can enrich the industry of architecture. This includes, but is not limited to, pathfinding within complex structures, character avatar design, interaction of 2 participants within the digital realm, representation techniques of metabolist megastructures. And if you, from my personal experience, just knowing you're kind of always up to, like, it's just like a huge kind of mix of things. It's always interesting to see. But every time you pick something, you go very, very deep down the rabbit hole into that thing. It's very fun to watch. So to remind, on our website, we have here a resources category, which has intro courses. I think we have some of your links here too. It might. So it's just links to good intro courses for each software. So make sure to check that if you don't know about that either. Real quick, everyone that's here in the audience, make sure to switch your chat to say everyone, and that goes for you as well. Just to make sure anything you want to send goes through. If you have a question about what's going on during the webinar, please use the Q&A button. So you see there's all these buttons in the tray. There's one that says Q&A. If you ask questions there, they'll go into this Q&A panel that we can easier keep track of, so things don't get lost in the chat. Just last reminder that not everyone learns at the same pace, and we want to give you as much content as possible. So if you feel the webinar is too fast or you're having trouble keeping up, feel free to just sit back and watch, and you can always go back to the recording afterwards. And just a reminder about the recording, which is described on our website, as well as the registration page that you had to click yes that you read it, that the recording is sent by email after the live, sometime within 24 hours when Zoom finishes processing it. So with all that being said, I think we can hand it over to you. If you want to start with share your screen, and we can just make sure that works, and I'll get out of your way.
Yeah, sure. Let's go for it. Share the screen. There we go. And bam. That should be that.
Yeah, we see it.
Blender and Rhino, right?
Yep, we see it. So I'll be here in the background, and I'll let you know if anything happens.
Okay, cool. if something breaks.
Yeah, for sure.
Great. So thanks for the intro, and hello everyone. So I've structured this webinar in a similar way of how I usually structure my lectures in the university, where we're going to kind of work on a big problem in smaller chunks. And of course, since we're dealing with a 5-hour, well, not limit, but a 5-hour estimate for this webinar, we will not have a really cool character at the end of this. But the principles will be there. I will show you all of the principles. And before we kind of jump into it, where do we begin? I guess let's begin with my favorite band is Aphex Twin, early Aphex Twin. Also, I like morphine, which is, design morphine, so that's kind of cute. But it is Epic's twin, and a lot of stylistic influence comes from their video clips. Also, my favorite manga is Tsutomu Nihei's Blame or Blam. If you don't know it, I suggest that you investigate it. It's really good. My favorite movie, animation is Ghost in the Shell. So you're kind of, as I'm kind of talking about this, you're kind of starting to piece together what's the aesthetic or the aim in which I'm kind of going towards, right? And hopefully it fits with what you find aesthetic as well. So before we jump right into modeling, I still want to show you the or rather talk about two principles of how I tackle these kind of a video game design-esque or video game character design-esque tasks. There are two ways, in my opinion, or in my approach. One way is by creating a Blender sculpt. So using Blender, sculpting out a soft body shape and then retopologizing it. And what I mean by that is here I have like a quick example of a Blender sculpt that I've done during one of the Zoom meetings that I just couldn't be bothered to listen into. So that was that, and it's, even though this looks, like it's getting closer to hard surface, it's actually all just a really, really messy mesh. And what I mean by that is, let's look at the blend file right here. So that's basically the blend file of it. And if I just select this, hit tab button, all right. Right. 1 second, hide that. So many spheres off, there we go. You can see how messy the actual topology of the mesh is, right? Because it is a Blender sculpt. But this is this level of detail is more than enough for me to start kind of getting ideas of how a form or the shape kind of pieces together into something that might become hard surface, a solid skin, if you will, right? So this was kind of a start of me thinking, oh, maybe I should kind of go into character development, right? Maybe I should develop this as a character. And of course it changed quite a bit, but by the end of it, I got, 1 second, Bunny Mecha, this project right here, the one that we used as a splash screen for the course or for the webinar. Let me open it up real quick. Like this one, right? So it has very little to do with the initial Blender sculpt, right? It's just some sort of a mass that is divided up into panels, but that is all it is in terms of not robotics, but like the view of robotics. Again, coming back to Blame, coming back to Ghost in the Shell, all of that is made out of these kind of separate plates that you can easily describe with incisions into your mesh and then retopologize them in Rhino. Let me show you that right here. So I'm going to show you this approach and how I work with this. We are going to create a Blender sculpt, and then we are going to retopologize at least a portion of it, manually, of course, so that you have an idea of how this is done. But we will stop there and we will take another route from there on out. We will talk about hard surface modeling and how you can create forms in a completely different way. So let's go for 1 second. There we go. CRT. The current project that I'm working on, have been working on for a while, and let's go for CRT retopo, I guess, or CRT, yeah, this one. It's a little bit on the heavy side, so it takes up, there we go. Okay, so this is initially, like this looks quite the same, right? Because both of these are sub-D geometries, both of these have certain topology associated with them, but the CRT is made, let's call it this way. The base geometry in which this character is made has been built up in Rhino and then retopologized in Rhino, while the bunny rabbit, this one, has been built up in Blender and retopologized in Rhino. And why do I use Rhino for retopology? You will have to wait for that once we start actually retopologizing. So I'm going to showcase, during this webinar, I'm going to showcase something relatively simple, perhaps a 3-part robotic assembly of an arm that we will use in Unreal Engine animated as an animated asset, right? There's no way that we will be able to do a full-on character. So that's our kind of our goal for today, is by the end of this webinar to have an animated asset in Unreal Engine playing in real time. Preferably textured, but we will see. So now let's jump back a bit and let's actually start doing like phase 1, not phase 1, like type 1 of form building. So I'll just, in Blender, I'll just create a new file, just a general file. I won't save the current one. And it's important, a very important thing, to select everything by clicking the A button. Wait, do I have screencast keys on? Let's try again. Yeah, there we go. Now here in the bottom left corner, you will see what buttons I press. That should help out a bit. So yeah, I'm pressing A to select everything, hitting delete, and then pressing Shift A, navigating to mesh, and creating a cube again. Very important. With memes out of the way, we want to make a sculpt. Let's do a helmet design, for instance, right? We want to make a helmet sculpt out of this box. Currently, if I just select the box and press tab, I can see that it only has, it doesn't have enough resolution. So I can only transform it with these 8 points, right? That's not good enough. Let me Control Z that. So we want to subdivide it. We want to give it more resolution. And there are 2 ways of how you can kind of work with this. One way is using subdivision surface modifier. I'm going too fast. Let me tone it down a bit. Selecting the box, going to the right-hand side menu, where you have the little modifier properties icon right here. Wrench, that's called a wrench. And then adding like a modifier on this, which is called subdivision surface. It's basically Catmull-Clark subdivision for those of you who use Grasshopper, right? Oh, it even says so here. And then as we are increasing the levels in viewport, you can see that the resolution, keeps increasing. So we won't go anywhere crazy with this. Maybe 5 subdivisions is gonna be enough, right? So we have something like this, and then we need to apply this subdivision modifier because, we don't want resolution that's lower than this for sure. Probably we want it even higher, but we'll get to that. So I click this small little icon thingy, small little arrow, and hit apply. This makes it so that now, these vertices that we just got by subdividing the surface, I'm just pressing tab, by the way, to get into the edit mode, and tab again to get out of the edit mode. These vertices are now like real. They're not a modifier anymore, but they're actual part of the geometry. And then to be able to quite easily jump between different levels of resolution, what I like to do is add another modifier, which is called multi-resolution. This bad boy right here, right? So as I add this, you can see that it doesn't really change much. And I could even go for level of the viewport. Let's go for whatever number that's not 1. And you can see it doesn't let me increase the number. And that's because you first need to calculate the subdivisions. So you need to click on subdivide here. And then you can see it gives you like 1 more subdivision. So subdivide again, 2 more subdivisions. At this point, stop pressing the button because it's an exponential growth, so you might crash your computers. Before we continue, I will expand this overlays tab right here in the top right hand side, overlays, expand it downwards and find statistics. Tick mark that. And now on the left hand side, it's going to show us how many triangles, edges, vertices, faces, how heavy the file is basically, how much geometry are we dealing with here. For an initial sculpt, you don't really want to go beyond 100,000 faces. I would argue that 50,000 should be more than enough. So this is where it becomes quite nice. I can go here where it says level viewport, and I can just click this button here that minimizes makes the value smaller, or I can type it in as well. Level viewport 1, and you can see here the amount of faces corresponds to it. So now with multi-res modifier, we can jump between different resolutions. Very, very useful, especially if you're dealing with a laptop, for instance, something that is not as powerful in terms of polygon representation. Okay, enough blah blah blah. Let's sculpt. So actually a little bit more blah blah blah. just a tiny bit more. So can you sculpt this with a mouse? Yes, absolutely. I've been doing that helmet that I showed right at the start, this one, this one, that's mouse, the body mouse. So yes, absolutely, you can sculpt it with a mouse. If you're planning on kind of pursuing this type of a workflow further, then I would suggest buying a tablet, a graphics tablet. What kind of tablet, you ask? I would say the cheapest one you can find that is not from AliExpress. So you want like a reputable brand tablet because you care about the precision of it, but you don't care about the size and all of the bells and whistles of it. Especially if you're starting up. So what I use is Wacom. Oh no, I should have prepared. 1 second. Wacom Intuos S. Wacom Intuos S. It's like $50 on Amazon. I'm happy with it. So as long as your tablet has at least 4 or actually at least 3 programmable buttons, you're good to go, right? So now I'm switching from mouse to tablet, and for some reason my mouse is still picking up. Please stop. Yeah, there we go. Now we're with the tablet, and I'm gonna show you my buttons. So if I just click here, I'm not sure if the overlays are showing. I hope they are, but basically I have 4 buttons set up for my tablet. The top left, undo, then I have F, control key and shift key. Undo key, F key, control key, shift key. The reason why I'm using F key is because it controls the size of the brush that you're using for sculpting. Quite useful. Shift key, control key are mostly navigation buttons. I'll talk about them more once we actually go into sculpting, which we should do now because we're running out of time. Okay, so in the top left corner here, I'm gonna choose sculpt mode, like so, and it basically changes my whole menu so that it's all of the buttons here or tools here, which you can, by the way, do this like expand or reshuffle, reposition. All of the buttons here are sculpt oriented, and we are not gonna use all of them. We're just gonna use like 3 of them because we're doing a very rough sculpt that we are going to be basing our retopology in Rhino on top of, right? So I'm gonna go real simple on this. Also, as you're just beginning to sculpt, when you're just getting the silhouette going, you don't want to be at high resolution with your sculpt. So wherever it says sculpt, and you can see now it says 2 for me in the multi-res modifier, I will drop it down to 1 or maybe even 0, honestly. Yeah, let's go for 0 for now. So I'm dropping it down to 0 just so that it's not in the way. So that it's, give me a second, lagging out. You don't want to push too many vertices at once, or too many points at once at the start of your sculpt. When you're just getting the form, the initial form ready, because the amount of vertices, first of all, it becomes slow very fast because, again, exponential growth of vertices. Second of all, the smoothing of the form is going to behave differently compared to how dense the form is in terms of points. So low resolution. One last thing I promise before we start sculpting, in the top right corner, we want to change the shading of this to be less gray, no highlight, to more of an indicative of the form that we're actually making. So I'm expanding this little icon right here, selecting matte cap, clicking the little ball, and then from here I can choose what is my preview material. So I usually go for the red one, for the clay one, but you can use whichever you want. Let's mix things up. Let's go for the skin tone one. No, that's gonna be very bad once it starts looking like a head. So let's go for the clay one. Okay, enough chat. We enable the mirroring, which is going to be, we want to mirror along the y-axis, which is the green one. So I tick mark that. I think we're correct. No, I was wrong. It's x-axis. Yep. So we mirror along x-axis, and you can see now as I'm hovering my mouse over the mesh, it kind of shows the other side, right? The other side where it's also going to do something. And if I kind of start drawing, it draws on both ends. The brush that we're going to use for now is actually the grab brush right here, or elastic deform. Why did I think that is grab? Doesn't matter. Elastic deform brush, this one right here. Not the snake hook, but the elastic deform. I can show you the snake hook just so that we're clear. It does these things. It's kind of nice, kind of cool. The bunny rabbit ears were done this way, but we don't need them. So instead we do elastic deform. Then here in the top, you can increase the radius, or you can just press F and just move the mouse or your pen to increase the radius. And I want it to be pretty damn big, right? Because with elastic deform, we will start making this into, something that resembles a head. So squishing it a bit on here, pulling it up here, the typical. You can always navigate to the side view and kind of work on it that way. And basically just getting the, the initial form going. So what do we want to do here? Perhaps something like this, and then, yeah, a little pill looking thing. Then make it a little bit smaller, maybe lift this one up a bit. Yeah, something like that. So at this point, it doesn't really matter as much, but we're just kind of adding, or not adding, we're just shifting points around. Then once you have like the silhouette, like just the very basic silhouette of how you imagine the helmet is going to look like, then maybe the top needs to be a little bit bigger. Sorry, I can't just look at it without fixing it up a bit. There we go. Then we want to add volume in, right? So wherever we feel like volume should exist. So for that, I prefer using clay strips. So you have draw sharp, clay, and clay strips. I prefer using clay strips tool with strength. You can see that strength here, usually you can only go up until 1, right? But if you select it and you actually type it in, you can go up until whatever you want, right? Whatever amount you want. So in this case, I'm going to be using strength 2. And now as I'm adding the strips, you can see that it's very, very aggressive in terms of just the, how do I say? The volume that's being built up, right? So now this is where we start planning things out and where undo button really, really starts shining. This is us basically just creating where form is and where form is it. Do we do a boldy? Maybe we do a bold character, or sorry, helmet. Something like that, and perhaps it connects there. Let's fill this in. Let's see from the front. So you're kind of just building up mass. If you feel like the resolution is becoming a little bit too low, right? In terms of how many vertices you have, you can always go in here, and where it says sculpt at 0, you just boop, increase it by 1, and now we have a ton more vertices to work with. So, and you can always go also back to the sculpt 0, right? So you can shuffle between these non-destructive remeshing, not remeshing, but non-destructive subdivision is the best. Anyway, so we're just kind of building it up. Don't worry if it looks weird or ugly or anything like that. We're okay with it looking kind of funky. Because in the next step, we're going to kind of start finding different angles that we enjoy. Chin? Do we do chin? Yeah, it should have a chin. Like that. Perhaps something like this. Yeah, something like that. And then maybe like that. Really don't want to mess with that area, so I guess we just kind of build it up here. Yeah, why not? Why not? All right, so we have, let's say, something like this, right? A beginning to something. And then we want to flatten things out and start kind of talking about the, not material, the surfaces, different surfaces of this design. Because right now it's super organic, right? It's super soft, but in the bad way. It's like soft where you don't really understand where things start, where things end, how things meet, what's which surface is which, right? So we are going to take a flattening tool. There are 2 or actually 3 flattening tools out there. The flatten, this one, fill, well, it's kind of a flatten, and a scrape tool. I really like scrape tool. Some people prefer flatten tool, but this is my webinar, so we use scrape. Scrape tool also needs a little bit boost in confidence. So instead of strength 0.7, again, we do strength 2. At this point, we need to kind of zoom in. So that's where Control key kicks in on our tablets, or scroll wheel. I can do this with a mouse as well. Let me show you with the mouse. So with the scrape tool, basically you're removing material, but at the same time you're flattening the material, what's remaining, right? So if I just take the scrape tool and just hit this area right here, you can see how it's both removing but also flattening the side of the helmet, or not the side of the helmet, but this area of the helmet, right? It's a little bit on the big side. Let's make it just slightly smaller, right? Let's hit this. So this resolution at this point, I feel like is a little bit, it's getting a little bit low. You could kind of work it this way and then increase and then kind of polish, but I feel like we can do one more level of multi-res for sculpt. So we're now at sculpt multi-res level 2, and we're continuing to kind of work these surfaces and try to figure out how are things connecting. So for instance here, that's an interesting area right here. I feel like I will decrease the strength of the scrape to 1 just to have a little bit more control over this, and slowly by moving my mouse, I'll start defining how do these surfaces meet. Oops, that was my bad. Yeah, with the mouse, you kind of need to do it a little bit. Like I always have my other hand on Control Z when I'm working with a mouse. If I'm with a pen, I'm a little bit more precise, so I don't need to use undo as much. But it is what it is. I mean, it's not that bad, right? So again, the idea of this is very simple. We're just trying to find areas, not areas. We're trying to, I don't like that. I'll need to remove that. We're trying to find how do these surfaces flatten out, and where do they all meet, right? Something like that, perhaps. And as we're kind of working on it, the helmet will just kind of emerge it by itself. It's actually pretty nice. And how do I say this? 90% of the helmets or anything that you do as a sculpt, especially at the beginning, you will throw away. There's just no way that you will not throw away. I also don't like that. By the way, to smooth things out, all you need to do is just hold the shift key, and go over an area. And it's just your brush becomes smoothing brush, right? So if you messed something up, you can always kind of go through it, smooth things out, and work it again, right? Try working it again. I will not, though. When I tried this out like 2 hours ago, or not tried this out, practiced this, it was looking a little bit nicer, but it is what it is. Curse of the live stream. Anyway, I'm gonna add a little bit more material in here. Feel like that's missing. That was a little bit ugly. I think this needs to be a little bit more pronounced. So I'm gonna do something like that. And perhaps this can then, taper off right here. So there are no, and just smoothing things out. There are no rules to how you need to work with a Blender sculpt. It's just matter of practice and finding whatever feels correct to you, feels good to you. While I'm doing this, I'll talk a little bit more. So one advice that I should give you is, if something that you're sculpting doesn't look kind of nice, if you don't see it coming together in first like 20 minutes, throw it out. Do another one from the scratch. If you can do the same idea, that's fine. But throw out that one, because that one you will just waste so much time trying to fix it. It's much better to just do another idea, or the same idea from the scratch. I see a lot of students who get stuck and they kind of try to polish a third, but you can't polish a third, right? You need to make it anew. Okay. You could say that this is what I'm doing right now, but this is a showcase. I need to do it to do it here. Okay, so we flatten that out, flatten this out, and now this is still quite soft. I feel like that's actually a pretty nice bend. Yeah, we keep that, we keep those. This is still pretty soft, right? So to sharpen things up and to make things come together, we will use one more tool. And that tool, 1 second. Still need to, that's a little bit on the annoying side. Zoom in. There we go. Make an emboss. Very important to have this sharp. The chin is, like you will notice in helmet design, the chin is, in sci-fi helmet design, the chin is so important. Okay, that's enough. That's enough. We will run out of time if I keep doing this. So one more thing that we kind of should do before we move on is creating, or two things. First one is creating really clear ridges. And for that, I use pinch, this one right here. Pinch basically sharpens everything. It kind of takes the vertices and where they want to form a corner, it just pushes all of them into that corner. And it's actually much easier to show than to say. And for pinch, if you just kind of go through an edge, and I prefer 0.75 strength, you can see how it's how it becomes sharper and sharper the more you go through a certain edge. Don't overdo it though, but as long as you're kind of mindful of how you see the curves behaving of the model, it's a really powerful tool. So that's what we're going to be doing for a little bit. Just sharpening it all up. Perhaps that can be pinched, that. Just trying to find, these angles, these corners. Don't, this is gonna be a webinar with a lot of don'ts or suggestions what not to do. Don't zoom in and zoom out too much, because the brush is, like the size of the brush, it does stay the same because it's pixel based, right? So as you're, that should be a straight line. As you're zooming in, you're initially increasing the brush size, if that makes sense. Or sorry, no, you're decreasing. If you zoom in, you're decreasing the brush size. So don't zoom in as much, or zoom in, zoom out. Just choose one zoom level that works for you and try to stay there. If you can't, then of course it's fine, but if it's better to stay at in one level. For instance, here you can see that if I zoom in quite a bit, you can see how big my brush becomes. So it's always important to be mindful of that, or else you're gonna be in a world of trouble later. Okay. I think in terms of sharpening things up, like just as a showcase, I think that's good. This is still a pretty boring helmet. One thing that I really like to do and that my students absolutely hate is what I'm gonna be doing now in in this showcase as well, is once I see the form, and I get the initial kind of flow of the form, I will mess it up by just adding more stuff to it and just trying out different things and seeing how how they might work or might not work. So be as destructive as possible with the beginning of your work, so that like you don't want to be married to the work at its early stages. You want to be able to really get in there and destroy it or rebuild it, or rather destroy it to be able to rebuild it into something that is better. So that's what I suggest to students as well. Let's go for strength 2. If that happens, by the way, like if this stuff starts happening where polygons are starting to intersect one another, then you either need more resolution. Well, first of all, you need to use this inflate button because it's most likely the form is starting to fold into itself, or even better, you can just remesh, because we don't care about the cleanliness of the form of the topology, right? So let's just apply this. To apply a modifier, you need to go out of the sculpt mode. So let's hit tab. Sorry, don't hit tab. Hit tab again if you did. Just here in the top, click on the object mode. Increase the level viewport to be the same as your sculpt level. So in my case, it's 2.2. Hit apply, like that. And then you want to remesh this to fix all of the kind of weird blobbiness that you're getting here, right? So we will go back into sculpt mode, like here. And here in the top, under remesh, we will choose to remesh it with a certain voxel size. What's the voxel size, you might ask? I don't know. Every size of the object is different. I know that the box that we used is 2 by 2 by 2 meters or units in size, so 0.1 might be too big. Let's see. Remesh. Yes, I would argue 0.1 is a little bit big. Right, so let's do Ctrl Z, undo, remesh. Let's try 0.01, remesh. There we go. So this whole thing here that we had a problem with now has been remeshed, and now we have a hole there, right? We have a hole there that can be inflated, or it can be smoothed out even better. So I'm holding the shift key and just smoothing it all out. And by doing so, we're just kind of making sure that the mesh will behave the way that we want it to behave, right? So unfortunately, remeshing is a destructive process and you can't undo it. So compared to multi-resolution, it's more destructive, right? But we don't care. We like destructive things. Okay. Let's hit it with a smooth again and redefine a few surfaces before continuing. I like this better, honestly. Let me show you flatten. So flatten button right here. I'll increase the strength to like 2 and just hit the middle of it. Yeah, it just flattens it. Poke, poke. You can also, instead of dragging, you can just click and like keep tapping. That sometimes helps out a little bit more. Different people, different preferences. I go back to scraping though. Let's make it smaller, increase this. See how this might work. So I don't like that. I feel like that's a little bit too much. So let's instead just work on this. Yeah, okay, that's good. Then this. So for instance here, right, this is something that I would probably solve with retopology rather than sculpting, because like the problem with the seams and it not being completely smooth, because it's so much easier to do this thing smooth in Rhino rather than doing it in Blender. So you always need to choose a tool that's best suited for a task. Okay, enough with that. So last thing that two last things that I want to show you are, first one, adding the eyes, or some sort of incisions, holes in your helmet. So I'm just going to grab a draw brush right here, and if I just use it, you can see, you can do like a quick little dimple here, sure, if you want to. But what I prefer doing is first making it negative. So here, this is kind of embossing, this is debossing, right? Or vice versa. Positive, like it adds material, removes material, right? And for the strength, let's do 2. And let's just figure out where we want the eyes to be. So probably somewhere here. Do we want one in the middle? Nah, not really. One here, like 6 eyes. Maybe, maybe one here. Well, why not? Right? Just kind of take a look at it, how it looks. Yeah, sure, why not? Right? So we're just doing like small little circles where the eyes will be. Then I will decrease the radius. This time I'm going to write it. If it was 41, I'm gonna do like 30, something like that. And strength, let's keep it at 2, make it positive so that it's embossing or going out. And let's just make the eyes pop like that. They're not gonna look pretty. Don't worry about it though. There we go. If at this point there's not enough resolution, let me show you one trick. Let's undo this real quick. And where it says here, dynamic topology, tick mark this. Oh, and at this point, save. Easiest way to crash your model is with dynamic topology. So save as, let me just call this helmet showcase, save. There we go. And now we can mess things up. So dynamic topology, expand this. We want, basically what it does, it remeshes only the area where the brush touches according to, in this case, the screen size, but we don't want that. We want it to be not a relative detail, but rather brush detail according to the size of the brush. And what I like using is 12%. So 12% of the brush size will be used to as a remeshing factor. And you can see the pixels here. They're not pixels. I want to say voxels, vertices. Vertices here, they're much denser than in the remainder of the model. We do this again. Messed it up a bit. Again, don't need to be accurate, just give it a little bit of filling in. Yeah, that should be fine. Okay, so we have like little doodads here that are rounded. We don't want them rounded. So I'm going to take the flatten, this time flatten brush right here. And I'm just going to zoom in, perhaps increase the size just slightly of the brush and just flatten it out. If you make sounds, it goes faster. So make sure that as you're doing this, repeat after me. There we go. Perfect. Okay. See, I didn't say for that one, and that one's a little bit awkward. So we have ourselves a helmet that is made out of clay. And it doesn't have any, what's the word? It doesn't have the panels, right? It's all made out of one material, one chunk. We want to subdivide it into panels, and this is, I promise, the last thing that I showcase with this approach. So I will go to, where was it? Draw, yeah, of course. I will go to the, my bad, it's crease, I got in my head. I will go to the crease tool right here. I'll make sure that it's set to negative. And what crease does is, if I just kind of showcase it here really quickly, it creates, you know, a crease like that. We will use this as a very, very aggressive tool to create very, very small panel lines for our helmet. So strength is going to be like 2. Radius is going to be much smaller. At this point, choose the like the size of the or the zoom value. How closely are you zoomed into the model? Because you shouldn't change it as you'll be working the model. So something like this. Size 15, that's too much. Size 10, yeah, that seems okay. Then we will go to dynamic topology, and instead of 12, let's go back to 25, because I noticed that 12 was very heavy. Let's change this from 10 to something like 7. I'm just looking, you know, how big of a gap do I want for the panel lines? Yeah, something like that. So I ended up having 5. Then under stroke here, under stroke, we choose stabilize stroke, right? You tick mark that, don't need to change anything here. The default stabilization is great. Now, as you're drawing, you can see that you kind of have this line that you're dragging around, which enables you to make sharp bends, and you're much more accurate when you're using this. And last one, fall off. I like to use, where was it, sharp? I think it was sharp, yes. I prefer using sharp fall off. So under fall off, we choose sharp. All right, so this is where things get a little bit naughty. And it's even naughtier because I haven't sharpened up this area before. So it's gonna be a little bit on the tricky side, but we just kind of draw panels like so. And they need to, of course, meet in the middle. So that's our first subdivision. Between the eyes, we usually just have straight divisions here. Then what happens here? Maybe it just goes along the curve, goes up, and maybe it can keep going, bends down like that, finishes up here. So we have ourselves, you know, that the first panel is here. And then for this area, perhaps there is like a, Oh, by the way, you should never do this. Again, this is a webinar of what you shouldn't do. Don't go from a corner. If you're making a bend, let's say there's a bend here, don't do this. That's naughty. That's bad. Don't do that. Instead, go from the middle of the curve like that. Just to help you out with the sci-fi aesthetics, you know. We could just kind of finish it up here, I guess. Or we could go all the way to there and finish it up there. Why not, right? Then we can have a panel here. By the way, you don't need to, you don't need to just draw it until it meets the other line. You can kind of make a pause and continue drawing from where you finished. It's not a big deal. So for instance, maybe something like so. It's a little bit, and then stop there. It's going to make a little bit of an awkward area. Oops, a little bit of an awkward area where the two panel lines not meet but overlap. But that's fine. That's for retopology. It doesn't matter. That. Okay. So stuff like that. And I will not, of course, I will not be doing it here until the, until we're, that was an ugly one. I will not be doing all of the paneling work for the remainder of the helmet. I believe you kind of get the initial idea of how actually it's done. And that's fine. That's actually fine. Okay. So those are honestly all of the techniques that I use for sculpting. And it's something that is very meditation based. And you just kind of sit down and you sculpt. And I would suggest kind of giving yourself like time every day for 15 minutes, sculpt something really quickly, and over time, you might end up being as good as me. Well, this doesn't show it, does it? Some sort of weird ass looking. Anyway, we save this, and let me just send it to you all over. I'll just give you a WeTransfer link or Google. Yeah, I'll do Google Drive link of this helmet so that we're all on the same page. So let's go for desktop, wherever I saved it. Don't remember. Yeah, there it is. 36 megabytes, by the way. Why can't I upload this? Hello? Oh, yeah, because I'm being stupid. One more thing while we're waiting for this to upload. I have updated like an idiot all of my software right before this webinar has begun. So if I don't find some sort of a tool somewhere, in the toolbox, apologies, because the new updates might have changed the position, like the way hotkeys or something like that works. So I might struggle with a few of them. With that out of the way, there we go. So I can now share. Anyone the link can view, copy. I will paste a link for download in the chat. There we go. You should be able to download this now. I'll give you like a, let's do like a minute. You download, you open, I guess, yeah, that takes like a minute. Whoa, that's a heavy one. Any questions so far, by the way? Any issues or concerns, suggestions perhaps, problems that we might solve? That needs to be softer. While we're waiting, the pinch tool should always be done before you start dealing with the paneling, because you can see that as I'm working on the paneling, as I'm working on a pinch right now to sharpen these things up, wherever I touch the corners of the panel lines, those get destroyed by pinching, right? So you never want that to happen. Crease makes creases too sharp. Well, it depends on how much you zoomed in, right? So if we're looking at this from very up close, I assume, yeah, there we go. I would assume that your crease doesn't look this way, right? It probably looks like much more like the eyes, the polygons around the eyes. To fix it, first of all, decrease the strength of the crease. Perhaps your strength is a little bit too intense. I do have the strength also being kind of not worked on, but adjusted through the pressure here, the pressure strength, right? So when I'm using my my pen, the strength value gets multiplied by the pressure value. So let's just see with the mouse. Oh, the mouse is still pretty fine. But yeah, the first thing, if it's too sharp, if it's too aggressive, I would just decrease the strength. I would decrease the radius as well. If you don't have enough resolution for it, then under dynamic topology, I would change the detail percentage. So make sure that dynamic topology is turned on, and I would change the detail percentage to brush detail and a lower value. Let's say 12, let me show you 50%. It's like that. 25%. It's like that. 12% is like that, right? And I definitely don't want to do anything lower than this, because already this is a little bit on the yikes side in terms of the resolution. Hope that that helps out. Those are like the two main things to look out for. All right. So I will assume that all of you who wanted to have downloaded the file and have it opened up, or you're working on your own file, which is absolutely fine. Now we will export this and open it in Rhino. So file, export, OBJ. We want it to be OBJ. And we will just export it. Yeah, I just have a folder set up here. Export it wherever you want. Helmet showcase, sure. There are really no options here that we care about, honestly. Anything that we need to do, we will do so in Unreal, in Rhino. Just make sure that selection only is unticked. Besides that, we're good to go. Export OBJ. Give it a second. Give it 2 seconds, I guess. There we go. Can you share the exported version? Sure. 1 second. OBJ. It's uploading. It's still uploading. There we go. And anyone with the link can view, copy, and in the chat. Okay. So once you have the OBJ file, we go for Rhino. New, no template. So a brand new file in Rhino, and we will just drag and drop it in, right? There's no magic behind it. You just drag and drop in the OBJ, you choose to import it, hit OK. I don't really mess with the settings here, hit OK. The only thing that you might want to mess with is like the Y orientation of the OBJ file, but like rotating it once in Rhino is not a big deal, so I just leave it. Now it's pretty small, which I don't like. So the first thing that I like to do when I import these kind of things is scale them to approximately correct size, you know, like 30, no, 25 centimeters. What's that? What's that in freedom? Almost 10 inches, something like that in length. More, probably. Let's go for a feet in length. Anyway, as long as you're within the kind of correct size, you're good to go. You will be able to scale this easily later to a character or whatever you want. So to do this, I just create a bounding box around my shape. Switch this to shaded view, and I just scale, type in scale, hit enter, scale between 2 points, you know, this point, let's say, and this point of the bounding box, and just type in whatever scale value or scale factor I want. In this case, it's value because we're defining, you know, the origin point, the end point, and now we're going to be defining the desired length for us. So in millimeters, I'll just do like 300. It's like a foot, I guess. What's a foot? 1, 2 millimeters. Yeah. So it's gonna be like a foot. Okay, delete the box. And here's our little helmet. Oh, by the way, my display setup. Let's go back to the bad display. So the mesh is pretty dense. That's the first thing, right? So we need to figure out how do we make it so that we don't get lost with this mesh. The second thing is the mesh is, after we finish scaling, the mesh is off center, right? So we need to have the world, let me draw this line. 1 second. Top view. We want this line to be centered, like to be like a mirror line on this helmet, so that when we retopologize it, that like half of it gets retopologized together with the other half that we are actually working on. Saves a lot of time. So I will just select the helmet first, bounding box again, select the bounding box, M, enter. So both the helmet and the bounding box are selected, M, enter to move. I click on the middle edge snap right here. If you can't select it, make sure that middle snapping is turned on here in the bottom. If you can't snap to anything, make sure that object snapping right here is turned on. If you don't see my mouse, it's right at the bottom of the screen. O snap, object snap, that's turned on. Middle snap turned on. We click on it. Now on the middle edge right here, and we can just throw it in on any point on this line, right? Wherever we want. Or you can just type in 0, and it's going to be thrown onto 0 enter, and it's going to be thrown onto 0, 0, 0 coordinates of the world. That's fine as well. Delete. Just make sure that y-axis of the world cuts the helmet in half perfectly. Okay, with this done, now let's do the shading issues, fix the shading issues. And the first thing that I want to work on is getting rid of the wires because they're really in the way and we don't need to see them. They're ugly, they're not nice, they need to go away. So under display settings, if you don't see them, by the way, you can click this little gear icon here, which opens up the options for the tabs, and you just find the display tab. There we go, tick mark this. Then you will have the display settings tab right here, and you will be able to, as you scroll down, find mesh edges, mesh wires. Untick that. Now you see your little element here, that's nice. Then you can go for object settings, color backfaces, turn that one on. And backface color, use something disgusting, like, no, not disgusting, something that you will notice immediately. Why did I say disgusting? I like red. Like purple, magenta, red, something aggressive. We do this because if now, after setting that up, we will be able to easily tell which side of any surface is the front side and which one is the back side. Right? That's the reason why we do this. For retopology, that's very useful. Okay, we're done with that. Now that this is object existing layer, that's the default layer. Let's make that smaller a bit. And that default layer, we need to create a new layer, call it subd retopo, for instance, or whatever you want. It can just be subd layer. Make it like not red, something other than red, and not gray. I like lavender. When I live stream, my viewers hate lavender, so I'm not sure why. We're sticking to lavender. We're going to do this in lavender. And then make this your active layer. Lock the default layer where your helmet is located. And at this point, you're good to go. You're ready to retopologize. Okay. How do you retopo? First thing is, where do you start from? Wherever you want. I like starting from areas where I am sure where I'm sure about the form, right? So in this case, it might be this area right here. I'm sure that this is going to be like a plate, or either one plate that kind of bends downwards. I am sure about, I didn't work this out as well. Well, this is also a plate where I could start working on this area right here. But easiest for me are these circles, right? These eyes, because I know for a fact that I want them to be circular. And this is where, in my opinion, Rhino is better at retopology than Blender, is because we can use CAD techniques to generate like CAD geometry, which will drive our subd geometry. So we're kind of going in between CAD and subd while retopologizing, while with Blender, you're not stuck, but you need to use more conventional retopo tools, which is also, something that's missing from Rhino. So there's a long argument, to be had about which one is better. I don't think that there is like a very simple answer. Let me put down my vacuum tablet now. We will not need the tablets anymore. CAD is a keyboard and a mouse game. Okay, so eyes, right? To create the eye here, a cylindrical, one second, I can do this, cylindrical subd geometry. I will just first create a circle, but not any kind of circle, but a circle that is forced to go through 3 points, interpolates through 3 points. So I select the 3-point option for my circle. I make sure that vertex snapping is turned on. And now by using my highly dense mesh, I can choose which vertices do I snap onto. And this is where students start struggling, is because, but it's not going to be perfect. What do you mean? We don't need it to be perfect. That's fine. This is our guide. This is where we kind of made a lot of design decisions as to how the shape should look like. And now we're just skinning the shape. If we will need to, we will move things around in the sub-D model. So don't you worry about that. Okay, so 1, 2, oh, now I remember 3. So 3 clicks gives us a circle, and now I remember why my viewers hated lavender. It's pretty hard to see it, isn't it? Okay, let's switch from lavender to like blue. Yeah, this is a bit better. Okay. If you hate the fact that it's how do I say this? 1 second. If you hate the fact that the mesh of the helmet is in the way of the geometry and it's kind of pushing through the geometry, you can always under options, under view, display modes, we're in shaded, so I'm going to choose shaded. Somewhere here, I don't remember exactly where, but locked objects, yeah, there we go. Locked objects become transparent, and we can do like transparency 50%, I believe. Oh, right, locked objects, not locked layers. That's a very important difference. So you unlock the default layer, select the helmet, type in lock, and now it's transparent. That was my bad. Sorry. So again, options, view, shaded, objects. You don't need to expand this. Locked objects, and you use these settings. And with transparency, I like using like 20 or maybe 10. Let's do for 20. Object appears transparent, 20. Okay, we're good to go. So now with this circle here, it's easy to kind of create planner circles. Let me do one more. 3-point circle, and just find vertices which you want to snap to, something like that. If you want to, you can make this bigger. No one's gonna judge you. One more. Actually, let's do one more here. This one. You don't need to do all 3, by the way. We won't have the time to retopo this whole thing as well. Okay, so we have these 3 circles here done, right? Then I will take each of these and I will offset each of these circles, offset inwards by whatever amount I feel like. So in this case, it's 0.02 millimeters for some reason. 1 millimeters, yeah, something like 1 millimeter. If you scaled the object correctly, 1 millimeter should look similar to what I'm using, right? So we have 2 circles here, 2 circles here, 2 circles here, and they're like in between them, they're super flat, right? Then I will use, we can do it 2 ways. I think the best way is to just start creating the sub-D. So I'll use sub-D loft. Sub-D loft. By the way, I hope that most of you know what a sub-D geometry is. Is there a way of raising hands on a Zoom call? I would just like to see somehow indication of how many people know what sub-D is, or rather, how many people don't know what sub-D is. Oh yeah, okay. So everyone who doesn't know what sub-D is, please raise your hands. 1. Okay. Okay, okay. So I will do like a really quick intro to SubD, but really quick one, like 2 minutes max. So SubD is basically a geometry type. So you have mesh and you have NURBS. And SubD is a geometry type that lives somewhere in between mesh geometries, which basically are a bunch of points connected with edges, and in between those edges you have polygons, and NURBS, which is basically NURBS curves defining surface, right? Or function-based surfaces. Is it function? Yeah, it's function-based. So in between these two, you have something that's called SubD. And SubD acts in a way as how you would think a mesh acts when you subdivide it, right? That's where SubD comes from. So for instance, here, if I just create a SubD box, and you don't need to follow along this, just a very quick example. SubD box, like this is the SubD cage, right? Or the flat version of the SubD. And if I hit the tab button, this is the smooth version of the SubD. And you can see it's smoothing out, and it works in a very similar way as how we saw the smoothing work in Blender when we created a cube. One second. And added a subdivision modifier to it. And for this to actually be accurate, I do need to do this once and then add another one. There we go. And just hit it a lot with subdivisions, right? So this is still a mesh, right? And underneath it, you can see that there is still a cube, and it behaves in a very similar way as to how this would behave, right? Well, it has like extra edge loop there, but basically it behaves in a very similar way. But this SubD geometry is able to be translated to NURBS very easily by just typing in two NURBS. Now we have a NURBS polysurface, which means that we can do Boolean operations with it, and so on, like all of the good stuff that comes with using NURBS geometry, right? Not that you can't do Boolean operations with meshes, you can, but it's a beast in itself. It's a pain in the ass to work with. So SubD is like a somewhere in between NURBS and meshes, its own geometry type that I absolutely love. Can you translate Blender's, like this, for instance, mesh into SubD in Rhino? Just import it, do mesh to SubD and then SubD to NURBS? Yes, absolutely you can. There is going to be like 1% variant, like difference, less than 1% difference as what you would get from like a fresh SubD geometry, but in most cases it's going to be identical. So the reason why we're doing it with SubD this time is because sorry, is because first of all, CAD tools here enables us to do like curves and use those curves quite accurately to create SubD geometries, which is very nice. Second of all, once we are done with this, and once I was done with the bunny rabbit, I really hope that I have it here. 1 second. Just give me a second. So much crap. There we go. So once we're done, we can, to be able to 3D print this bunny rabbit, I had to separate it into separate parts, right? that was Boolean, those were Boolean operations in themselves. And also those parts had to, why can't I, hello? There we go. And also all of those parts had to have like positive and negative plugs so that they align well enough, you know, for this whole thing to work. So subd is really great if you're planning on manufacturing something. And that's why I use it. Okay, intro over. So now to create subd geometry from, let's say, 2 rings, the tool that you use is, well, to create a surface, you would use loft, right? With subd, you use subd loft. Subd loft, adjust edge loop position, like that. And here you can specify how many segments you want, right? So in this case, it's creating 8 segments, and you can see it's a little bit on wonky side. If this happens, by the way, I would suggest that we just cancel out of this. And if you don't want to deal with the loft options that you get there, you can always easily just select your shapes that you're about to subd loft, and instead of just saying that, oh, it's just a perfect circle, select both of them, rebuild, choose how many points you want, how many sides you want, and you just hit okay. Oh, by the way, degree needs to be 1. It needs to be a polyline. And then you'll know exactly, you will see exactly how the polygons will kind of array, right, around the eye or this cylinder. Delete input, yes. Let's hit okay. Let's do it for other 2. Okay. Now if I select this, subd loft, you can see that, you know, it's still trying to ask me questions, but now it's a perfect circle because octagons make perfect circles. So do hexagons, to be honest, but in my experience, hexagons don't have enough resolution. So I prefer to use octagons. Don't use heptagons, don't use 7-sided n-gons. That usually is bad. I don't know, I would need to think about why does it make issues, but something about it being a non-even number makes issues as you're kind of trying to connect all of the geometry together. Either way, we're done with this. We have our 2 rings. Now we want to, by the way, tab button switches between the soft and the hard or cage mode. Now to fill them in, I will just Control Shift, holding Control Shift, double click the edge, or maybe I don't need to anymore. No, sorry, it was a new update. You don't need to anymore. So don't select anything. Just type in fill. Type in fill, enter. Select subd boundary edges. You select the any inner edge of your subd boundary. So for instance, this one right here. Hit enter. And it's gonna ask you what's the type of the patch or patch style. So you choose always triangle fan. If you choose automatic, it's going to kind of try to make quads and it's not going to smooth nicely. Triangle fan for cylinder type geometries. Triangle fan makes it like so. We have ourselves a circle, right? Yay. So I'm gonna do this 2 more times. Fill, select, triangle fan, fill. I'm not sure if it can do many geometries, many holes at once. I don't care. Then we type in cell CRV, don't really need it. Delete, and we have ourselves 3 circles. Yay. Moving up in the world. You'll notice that the circles are, we are looking at the backside of them. At this point, I will select all of them and type in flip, just so that we're, you know, the backside is in the back of the helmet and the front side is in the front. Now I will move in the circles, right? So to do this, not move in, sorry, I will extrude in the edge of the circle. So the way you do this is Control Shift, hold Control Shift, double click on any of the outer edges, which will give you, the whole loop, the whole selection. This is how you do select the whole loop. And you choose to, where are we? Here in the bottom, under gumball, right now it's set, if I right click the gumball, you can see that it's set to align to C-plane, which is by default aligned with the world. And the gumball is X, Y, Z of the world. We want it to be aligned with the object that we have selected. So I'm going to choose align to object, like so. Bam. Now we have it aligned. And you can see the Z is now perpendicular to our outer ring, which means that now we can extrude it inwards into the helmet. Yay. So I'm going to take, if you just take the arrow and move it, it moves the ring, right? That's no good. We want to take the little dot. Perfect. This little dot right here, that's the one that we want to click on. Click and drag, I mean. Or you can click on it and type in the amount, how much you want to extrude. So let's try like, what's a good amount? Let's say minus 20 millimeters. That was not a good amount. So I'm going to undo this and try again with, let's say minus 5. Yeah, something closer to that, right? And I'll do the same procedure. Oops. I'll do the same procedure for the remaining two. I will use the helmet as a reference just to see how much. So this one maybe minus 3. Yeah, something like that. And this one maybe minus 7. Is it enough? No, it should be more. Minus 9. Yeah, that's better. That's better. Okay. So we have ourselves cylindroids, three of them. Let's work on 2 of them for now. We basically want to create a little gap that you see here, right? This little gap, and then extrude them out again to meet with the outer shell here, right? So to do this, I will just take the cylinder, this whole edge loop, Control Shift, double click, duplicate edge. That gives me the polyline here, and I'll use the polyline to offset it. See how I'm using these CAD tools constantly? That's why. That's why I prefer retopologizing robots in Rhino. Sub D loft, like that. Delete. Select both of these, join them up. I'll repeat this one more time. This one I delete because we don't have the time. So it's just going to be the bottom one. Dupe edge. Select the curve. Offset 1 millimeter. Sub D loft. Just keep hitting enter until it's happy. Until it gives you a loft. And join both of them in, right? Now we have these 2. Now it's time to actually start connecting them. So while I do have, I could kind of stop it here and, or sorry, not stop it here, but continue and grow this out to meet the ridge of the helmet and so on. But I feel like it's more important to start surfacing the shell of the helmet and then connect it to this bottom ring right here, because the bottom ring might end up needing more polygons than we actually have right now. So it might end up needing more than 8 polygons here, maybe 11 here, and maybe 13 here, right? Depending on how this whole thing kind of connects into a network of polygons. Right, so to do this, I will just go to my Sub-D Tools tab here and click on the little Create Single Sub-D Face icon right here, the tool icon here. Click that. And I will, wherever I'm pretty comfortable with adding rectangle, a rectangular piece, a polygon, I will create a polygon. So let's see, perhaps something like this, this, and then it goes until here and connects to here, let's say. And you don't click the 5th time, you do only 4 polygons and then you hit enter. You hit enter, I said, there we go. And it gives you the first kind of face. That's all you need. That's the first face that you need. And if you want to, then you can take these two edges, Control Shift, click first one, click second one, and type in bridge. And this gives you a bridge between the two edges, right? Exactly what it does. Anyway, then to add more polygons to this structure, I will append face. So you don't keep creating these polygons from here, from single sub-D face. You rather use append face. You select the mesh, the sub-D, from which you will, to which you will be adding more faces. Hit enter. Choose that you're going to be appending the face from edge. Yes. And now it's basically asking you, okay, so what's the edge? Well, what's the edge from which you would like to add the faces from? Okay. So for instance, we select this edge and then we just do, yeah, this is where it starts becoming another time consuming thing. So once you're done once, you hit enter, find another one. Let's say it goes, where does it go? Let's say it goes until here, right? And you will notice that I constantly am trying to, something like that. I'm constantly trying to draw them as rectangles. You don't need to draw them as rectangles. That's fine. You can do triangles, but you definitely shouldn't do n-gons. You shouldn't do pentagons. You shouldn't do, well, for instance, here I'm gonna do a triangle. Why not? Like that. You shouldn't do pentagons. You shouldn't do hexagons. Nothing like that, because meshing them will be quite a disaster. By meshing them, I mean later stages will be quite a disaster. Okay, and that's basically it. You know, at this point, all you need to do is just go around this whole area and slowly cover everything in patches. It's not not the most glamorous job, but it does need to be done, right? Oh, and if you mess up, you can always Control Z. There we go, something like that. And let's bridge a few. So for instance here, right, I bridged these two and I bridged these two, but now I have a little bit of an issue with this triangle because I can't bridge the triangle. Oh, come on. Can't bridge the triangle. That doesn't work. And also here, that might be a little bit awkward, but that's fine for us. So for a triangle, I just type in fill, select the edge, enter, just gives me a, you know, fills in that particular triangle. This one can be bridged though. All right. So now, final things to show you, because we are not doing the whole full helmet, as you can probably tell by now. Final things to show you. First, thing number one is reflection, right? So I remember when we positioned this along the y-axis, that was on purpose. If I select my sub-D now and I type in reflect, enter, and I say that it needs to be reflected along the y-axis and hit enter, now I have it in both ends, right? And I can kind of use this to my advantage. So I can, let's do a quick one. Append face from, oh yeah, the subd from edge. There we go. And let's just quickly build up, sorry, not in, build up this little ridge here. That, like that. I used to try doing like a Grasshopper script to automate this process and so on. Nah, nope. Technically, you could try, like, how do I say this? It works until it doesn't. I think that's the best the best way to explain why I'm saying nah. And when it doesn't, it takes a while for you to understand why it doesn't and where the mistakes are. So there's a lot of a Grasshopper, a generalized Grasshopper solution for these kind of ridges really likes shitting on the floor and then hiding it under the rug. I think that's the best analogy. And then you're working on the model and you're thinking something smells, something's bad, and you can't find what the hell is bad until it's a little bit too late, and then you need to redo quite a lot of things. Hope you got what I was trying to say. Anyway, now for these, I think we can just bridge between them. Yes, we can. So I'm just creating a bridge here, and perhaps here. Let's finish this one up. And here is gonna be, yeah, this is one of the, it's not a disaster, but one of the main issues that you might encounter later down the line. And the way you solve this issue is by adding edge loops. Sorry, first of all, issue. What is the issue? The issue is we have 1, 2, 3, 4 polygons that are trying to connect to a single point. That is a no-go, right? So what you can do is you can select this edge loop, for instance, here. I'm not sure why it's not. Oh yeah, it's because this is a triangle. So selecting this edge loop here, double clicking, Control Shift double clicking, insert edge, inserting the edge to, let's say, yeah, something like this, to the middle, right? Something like that. Then saying that, okay, I do agree that these two edges can be bridged between, right? And then this edge bridges with, one second, if that's a triangle, then this bridges with this, and that gets filled, right? And we have like this kind of a topological solution. I'm being generous with the with the words. I'm not sure if that's really a solution, but hey. So we're bridging it that way. Then for this part right here, this is a problem because this becomes a pentagon, and we can't have those. So how do we solve this? Well, I think the best way to do it would be to either stitch these two or stitch these two. Wait. Are you thinking what I'm thinking? I think you are. Yep. So if we just delete that edge, this becomes a hidden quad. 1, 2, 3, 4, like a rectangle. So we don't need to do anything there. It's a little bit on the awkward side, so I'm going to select this point and slide it. And slide it across. Okay, fine, I'll use the move button to do something like this, because when something looks like a triangle, you don't really, you want to fix it up so that you visually can tell that it's not a triangle. Anyway, so that's, you know, That's the principle. That's the principle of how sub-D array topology works with sculpting of meshes. And I would go over this whole helmet. I would create the whole sub-D for it, and then I would take a second pass, add a sub-D, making things sharper where I want them to be sharper. For instance here, right? What's a quick example? Now, since this is like only half done, it's pretty hard to show you a quick example, but let's try. So let's say this ridge right here, or not ridge, sorry, this, oh, I know, this plate right here. Let's go for this. This plate right here, let's say you want it to be sharper. So you want like this whole area to not be as smooth. You just select this whole thing. You don't need to care about the other side is going to kind of translate. It's going to reflect, like mirror to the other side. And you type in inset, enter, as a group. So mode group, enter. Inset distance, basically how much of an offset, inner offset do you want to give it? 0.1 seems like a pretty good solution. So I'm just going to give it 0.1. And now as I hit tab, you can see that this became much sharper. Let me show you with EMAP, right? We have just sharpened up this area, right? So doubling of any face. Let's take a look at the model. For instance, here, right? We want this to be sharp. Inset. Right? Like that. Perfect. That's a better example. So doubling of any, not face, sorry, of any edge will sharpen that edge. It's going to, the sub D will hold shape better at that edge. So keep the density of your sub D geometries matters. Right. So that's the showcase of version 1 of how I create these kind of designs. It's everything besides this is just like you just kind of build up on it and then continue, just keep on using the same tools over and over and over again, and it's just a matter of practice. Let me save this file and send it over to you just if you want to have it. Let me call this showcase Helm. I feel like sub-D portion of the showcase is pretty accurate, and like there are no major mistakes here except, you know, like this edge right here, but that doesn't matter. But there are no major mistakes, so I'm comfortable with giving you this as a probable reference for you know, your work later down the line. Okay, showcase Helm. There we go. Let me just upload this real quick and I'll share it with you guys. And with this, we will have a small little like coffee pee break, 5 minutes. Let's not waste time too much. So 5 minutes, and now it's well, for me 5:57. So 2 minutes past whatever hour you will be at. So 2 minutes past, we will continue the showcase, and in the chat you will see a link, which you don't need to download, by the way, to keep up, just for those who are more interested. 5 minutes. Okay. For those who are interested in terms of what are the computer requirements for this kind of a workflow, I just want to do kind of anecdotal, like from an anecdotal experience or whatever, a story. I started doing this with a laptop that had like a GTX 1650 in it, and it's absolutely fine. So while we're on a break, I can show you the game where the bunny mecha actually was implemented, and this game does run on my like old Dell XPS laptop, like business class laptop. I hope that it's not going to be too annoying with the sound, or I'm not sure if it even showcases the sound, if the sound transfers. But yeah, here's the bunny rabbit. So this was created exactly in the same way as to how I showed you. You know that the workflow for it was exactly the same, and this was you know the other project that I worked on, the little space and the game. So what I wanted to say was you don't need intense hardware to do this kind of stuff, because most of this structure, and I probably should show this from the outside, most of this structure was like developed and created with that particular laptop with GTX 1650, 16 gigabytes of RAM, uh, some sort of a Intel i7 laptop processor. And the megastructure itself is, I don't want to lie, but I think it's almost a billion. It might be around 700 million polygons. And of course, with my RTX 3080 graphics card, it's running at 120 frames per second. But oh, on Zoom, it probably doesn't look like it's running 128 frames per second. Sorry. But on a laptop, it was like 60 frames. So as long as you optimize things pretty well, you still don't need insane computers to do this or develop this kind of stuff. 2 more minutes. Also, while you're learning this kind of stuff, I suggest ibuprofen. It's great. Coffee and ibuprofen. Okay, 2 minutes. So, did I send the file? Yes, I did. Okay, good. So now we are going to go for the second route. Second route, how I work with geometry. And the second route is much more CAD focused, I guess. And it's you sculpt. You still think about the geometry creation as a sculptor, not as a like a CAD specialist, or not as a parametric specialist, right? So you still think of like form, silhouette, carving, adding, and so on. But in this case, you're not using brushes, you're not using Blender for this, you're using Rhino and the tools that are available for or in Rhino. So as an example, let me by parent, what? Okay, sorry, file, new, no template. Is this new? Why does it give me an additional? Yeah, this is why you don't update stuff right before the webinar. Anyway, let me just delete that layer. So for this showcase, I'm going to do a leg or an arm, I don't know, but something that has joints and that is able to move and be animated, because, you know, that's the end goal. To have something animated, of course, not a whole damn character. So I'm just going to, in the top view, just going to create boxes. I'll start with boxes and I'll carve into them, right? You can do cylinders as well if you want to, but I prefer to just kind of start with very simple boxes. And we're going to work out some the scale and the proportion of a thing, an object, right? So I'll begin with just creating a box from 0. Doesn't really matter where it's located. Let me just kind of make it very apparent that it doesn't matter. And I'll think of some sort of a size for it. Let's do like 50 centimeters, so 500 mil, like almost 2 feet by, in this case, 150 mil, half a foot, and 150 mil in the in height. Let's say this is joint, not joint, but segment 1, and then I'll just make a copy of it, put it in here. That's going to be our like segment 2. And later we will figure out how do these two move, and perhaps we can be a little bit funky with this and just make a copy of this box here. And at this point, I'm just gonna scale I'm just gonna scale things aligned to C-plane so that it's gumball, right click, align to C-plane, so that it's the gumball is right in the middle of our object. Just scaling things and kind of blocking out the, not even the shape, but just the proportions that I'm after. So perhaps something like that. Do we want it to do something there? No, it can be a spiky boy, so let's just do something like that. Yeah, perfect. All right, so that is like our first step, is kind of getting an idea of how do we want this whole thing to work, to look like, and where the joints will be and where they will be not, I guess. Then the next step is to actually start kind of drawing and carving into the shapes. So for this, I do like to use some sort of a reference, some reference photos that I find on the internet. And let's just say I just type in human arm anatomy, you know, something very simple like that. Perhaps that might be better, or that, yeah, something like that. And just drag it. For this, I'm using Pure Ref, a pretty good software that just enables you to have multiple images that you can just drag on top. Muscle groups, not that interesting. Maybe something like this. A little bit better, make it bigger. I said bigger, there we go. Perhaps the last one, let's go to images. I'm scared of showing something bad. when searching for anatomy, you never know. No, you never know. This seems, yeah, this seems good. So I'm just gonna drag this one in as well, just to have it there. That's it. Enough gambling with the Google search. There we go. So let's say I want to do just like shoulder middle joint, you know, this area right here. And then we definitely don't do a hand because, oh no, that would be a little bit too much, right? So for this, let's focus on isolate. Let's focus on this area. In the top view, I'll start kind of drawing out the curves of how I feel like this should look, right? So I'm just going to quickly take a not node, too used to Grasshopper, take a curve tool, NURBS curve tool, and just draw something out. I would say, wait, let's take a look. Yeah, this one should probably be, come on, maybe like that. If the snapping is annoying, just turn it off. You don't really need snapping for this stage. Sorry. So maybe, bam, bam, 2 points here, and then it just tapers down quite drastically like that. Bring it in, and then mess around with the points. You know, reposition them. I will be using this as my cutting surface, right? So that's you know, that curve is going to be used to cut away sides of the box. So that's, let's see, one. The other one, let's say, starts from here, or maybe here, and just does a very soft, yeah, a very soft curving like that. Then we go for the perspective view. This is those two curves. I will just make a copy of them to the opposite side. I could just mirror them, by the way, but I feel like we don't really need it to be symmetrical. So I'm just going to copy them slightly above the box. And at this point, you can choose how much control you want. What I like to do is tween curves. We select the first kind of section curve, the second section curve, and we tween between them, right? So we create a bunch of curves in between. Well, we don't need a bunch, we just need like one or two. I prefer to just do it with one curve in between. We hit enter, and now we have one more. And this one can be, actually, let's lock this box so that it's not so much in the way. This one can be a little bit more, you know, extend that out a little bit, going a little bit more out, like that. Do we need anything else to change here? No, I think that's good. Let's just loft them to see how the surface looks like. It bends, but I wish it bent a little bit more. So I'm going to take those two control points here and move them actually a little bit more out. That's fine. We can adjust the size of the box as much as we want. So something like that. Push them in a bit more. Loft. Yeah, that looks better. That looks better. Okay. And then the same thing for this one. Tween. There we go. Grab some control points. That's pretty easy. Or rather, let me show a different approach to this. Sorry for jumping back and forth, but tween, and this time number of curves. Let's do like 5 curves. My bad, not 5. Let's do 4. Yeah, perfect. 4 curves. Delete the second curve and one before the last, so that you only have 2 curves in the middle, like that. Hit F10 to get their control points and move both of their control points simultaneously, right? Outwards, for instance, like that. Yeah, something like this. Now take the bottom one and holding the Alt key, just copy it, not too much, but just a little bit down, like that. Take the top one, holding the Alt key, copy it slightly up, like that. And now I'm just going to select all of these, type in loft, and you can see that, sorry, and the style of the loft needs to be loose. And you can see that in doing so, we're basically creating a flat area in between the two curves right here. If this is not, should be flat. Am I missing something? It should be flat. Yeah, I think it's flat. I think I'm just having a stroke, or maybe. Anyway, if it's not flat, that's an easy fix. You can just easily just loft the between the two middle ones first, and then loft the top three. There we go. Smooth, or yeah, smooth, loose loft like that, and loose loft for the bottom three. There we go. And just join up the surfaces. Once that is done, you have two lofts that you can use to trim the box, right? The box with. And I do like to do this in steps. So we just take the box, we scale it up to make sure that it's properly being intersected by the surfaces. Yeah, properly intersected. That's a key point. Let's move the surface just slightly down, just to make sure that everything's gonna work. We don't need the curves anymore, so I'll just type in cell CRV, hit delete to get rid of the curves. If you want to just create a separate layer, place them there, hide the layer. In this case, I usually am very destructive in how I work with this type of stuff. Then we select everything, type in trim, enter, and we just trim away the ends of the box as well as the extra surface from the flaps as well. Type in join, and we have ourselves the first kind of a cut made from the first projection, right? Very hard to see what actually is going on. I prefer to use EMAP to see if I like the form. And one thing to note is that it's always going to look like shit. The first working on every form, first like 20-30 minutes, it's gonna look like shit, and only then it's gonna start slowly looking a little bit less like shit. So just keep that in mind. I will repeat this step for, of course, the other direction. So bear with me real quickly. Let's go for ZSA, zoom select all, front, and I'm gonna go now pretty fast just so that we're not wasting much time. So bam, make a curve. That was my bad. How do I want this? If that is that, I kind of want it to bend outwards, right? So let's try doing something like this. Two ones there, and bum, bum, something like that. And perhaps just to save time, I can just mirror it like that. Go into top view, drag it out, copy it, make copies, make copies like that. Right. And now for the top, twin curves. Oh, here I'll just use two like this, like so. Lock that, so lock the main body so that it's not in the way. F10. And we just kind of mess around with the middle ones, right? So these can, what if they dip, right? We're just kind of experimenting at this point, but what if these two dip and these two go up just slightly and these ones stay? And these ones, tween F10, you again, you're working like a sculptor in this case, right? So you need to be brave, is what I'm saying. You need to be brave with the different approaches and different kind of this decision making. So the decisions that you do need to be pretty out there, just so that. Sorry. While I'm thinking, it's hard to talk. I'm thinking if I should loft it in a smooth way, sorry, in a loose way or in a normal way. I'm feeling like it needs to be quite aggressive, so I'm gonna use style normal. And normal fits the loft through the curves, right? So it forces the loft to go through the curves. I feel like it's like this more aggressive style will do the trick better. And we do the same thing here. Okay. So where was I? Being brave, right? At this stage, if you're not brave enough, it's gonna look very, very boxy. Your object, your model. So you do need to be quite drastic with how you work with it, and how much of it you're actually cutting away. Okay, we're good here. This is gonna be a problematic area, but not really. Later down the line, it might be. The fact that it ends at a rectangle is not an issue, actually. So we have ourselves, you know, some form or some sort of a outline of the first part of the arm, the robot arm. Then if I show, then I remember that I actually have joints and so on. But for me to do the joints, I need to fix the second arm. And I will do that by isolating these two and just kind of drawing, really, yet again. So let's do the second arm pretty thin. Oops. If you want to work with fillets, you can. You can work with fillets. Meaning that it doesn't need to be a NURBS curve. It can be a polyline, and you just fillet corner, and you give it like 200 mil fillet, and you know it's kind of a little bit of a smoothed out one. I personally prefer to use NURBS curves. The softness of it, I feel like that's what Rhino is powerful for, right? Why we use Rhino in the first place? So might as well use it. That is too thick though. Make it like that and bring it in here. Oh, I know. What if we just do something like this? Yeah, perfect. All right. So what if the bottom is just an extrusion? So it's just a flat piece. Bring it a little bit back. Like that. And the top is, well, the top we will need to work on the top a bit. Mirror, hello. I'm trying to go as fast as possible to showcase like more stuff for you, but these things take time. It's not like you can you know, press a quick little button and they're gonna become cool. You need to work them out for them to become cool. F10. I'm thinking of just moving the two curves up manually, like that. Let's just loft. Okay. Trim, join. Loft, trim, join, loft, trim, join. That's all that matters at this stage, yeah. right? That's all that we're doing. And for instance here, I might go for something a little bit more intense, perhaps something like that. This kind of a design. And maybe these 2 points, I'll just scale them to 0 so that they're aligned, you know, along that particular direction at which I scaled. And I will use some sort of a last curve, oops, like that. Okay, let's see. Let's take a look. Can we just do this, honestly? I think we might end up doing this just to save time. Trim away some stuff. I don't like that. Sorry, I need to give it a little bit more breathing room there. It got too narrow, way too narrow. Okay, so now we just do some trimming. Zero magic, just boring trimming. Okay, and we basically at this point have ourselves, you know, 2 forms. Now the way that these 2 forms connect is absolutely up to us. I do like for let's find CRT images. Like I am a fan of these kind of joints where you have double rotation values, where one joint kind of, sorry, where the joint is made out of 2 parts that can rotate, that are locked to certain axes. And I use that quite a bit for the CRT. You can see here, like these kind of joints right here. And honestly, like everything is those kind of joints. So cylindrical joints. So I'm thinking we are going to be using that for this particular showcase as well. In the front view, I'm just going to create a quick little cylinder, something like that. The size, the depth of it doesn't matter. I'm just going to position it something like so, something like that. So let's say this whole arm is going to be able to, or portion of the arm is going to be able to rotate like that around the cylinder, right? It will not be able to twist though. So we need to create a secondary cylinder. Oh yeah, and at this point we do move it out. Control Shift to select a surface. We move it out, and we do need to create a secondary cylinder around which this cylinder will rotate, right? So 1 second, I'm thinking. We just rotate the cylinder 90 degrees, holding the Alt key and Shift key, like so. Move it until it's kind of meeting the object. You could make them, you know, in the perfect T shape, but I feel like that's unnecessary. In terms of aesthetics, we can just kind of increase the size of it to make it a little bit more aggressive, you know, something like that. And I think that's going to be fine. So 2 cylinders. One is able to kind of, because of the big cylinder right here, this joint is going to be able to rotate this way, and then the remainder is going to be able to rotate this way, right? Okay, so now to make it all work, or all work fine, which cylinder is a part of which part, right? So first of all, there needs to be an incision in this cylinder where this one fits, right? Because comparing to these two, not comparing, when we're looking at these two parts, this part and this part needs to be separate, right? Because they're moving independently from one another, while this part and this part, these can be the same part. Or alternatively, if these are joined, if this is one big part, then these two need to be separate. So it's absolutely up to you. For me, I am thinking of, let's separate these two parts. So I'm just going to take this cylinder, and I'm going to, holding Alt Shift, I'm going to scale it up just slightly, and I will use that to Boolean difference from the big cylinder with the scaled up version of the small cylinder. Delete that. Now we have this gap here, and this gap is fine. I mean, technically you want the gap to be a little bit smaller, but it's fine for what it is, right? And then here, to make it nice, why don't we, one second, I'm gonna think for a little bit, just tiny bit. Okay, why don't we Boolean difference from this forearm with the cylinder? So we're creating like a hole there, but then we will take Control Shift, select the face here, and we push it in just until something like so, thus opening up like this whole area and then kind of showing the inner workings. You could have like pretty cool machinery shown here, you know, and so on. So it's like off center cylinder right here. And of course it needs to be a little bit smaller. And at that point we just say, okay, these two, Boolean union, and now they're one part, right? Then coming back to here, this looks pretty ugly. So to make it look less ugly, let's see what we can do. I'm thinking of creating an extrusion. So I will Control Shift, select a face, this face right here, holding the Alt key. I will click on the little extrusion, like that little circle always is used for extruding, right? So I'll click on that and drag it out, something like this. Control Shift and scale this down to just see how it kind of fits with the remaining of the arm. It's not great, ain't gonna lie. I guess that's the name of the game for this whole webinar. Showcasing stuff, but not necessarily making it real pretty. Anyway, this actually, now as I scale this down, doesn't look that bad. So we're going to stick with it. And now let's just Boolean union everything here together. Boolean union, great. So we have this part right here. Now thinking of how would this part kind of connect and so on, you would probably have like extra geometries here that connect and extra geometries here that kind of help out. That corner though needs to not be there. So you either need to Boolean difference out or Boolean union out on some sort of a form here so that that corner does not exist, because that is definitely going to be a problem. And just aesthetically, when things are meeting this way, not good. So we will need to work on that. But besides it, I think as a like the starting concept, this this kind of showcases all of the tools that I use. It's mostly trimming and Boolean unioning things and thinking about what's connected to what. Said that, this goes away. There is the last bit here that we can actually just make nice. Make a cylinder out of it, or a sphere. We can do this into, we can make a sphere. Sphere is basically, if I have a, 1 second. You almost can see it. So a sphere is like a ball joint. That means we kind of want to give it full freedom of rotation wherever the sphere is. Is there like a better place to show it? Yeah, unfortunately I can't find a better image for it. Oh yeah, there we go. Like a sphere in a socket, right? And that just enables like a full-on rotation. But in this case, since we don't have anywhere where to connect that sphere, it will look a little bit awkward. So instead, we are going to do another cylinder and just call it a day. So I'm just gonna draw a cylinder anywhere in the world, rotate it, position it. Would be maybe a good idea to like have a pretty clean vertical, or sorry, horizontal axis. So to do that, I will just, get centroid of this circle right here, for instance. Come on, give me this circle right here, area centroid. It just creates a point. No, it doesn't. Never mind. We do need to dupe edge and then type in, for the curve, type in area centroid. And that gives us, should give us a point. Hello? Am I losing my mind? Area centroid. Select surfaces, closed plan. Yeah, it's a closed planar curve. Okay, we type in Grasshopper. If something doesn't work, just type in Grasshopper and make it work in Grasshopper. So in Grasshopper, we just reference in the curve that we have just created as a CRV. Oh, I hope you are familiar with Grasshopper. If you're not, I will not be giving an introduction to Grasshopper. Just when you type in Grasshopper, this window will pop up. Then type in, double click inside of that window and type in CRV, short for curve. Select the black hexagon. Without having anything selected on in the Rhino viewport, right click on the orange little node that you have here, set one curve, and select the circle, right? So now this gets referenced into Grasshopper. And then we will just do area, double click, type in area, get that in here. Oh, so that was me being an idiot. It wasn't the program. I'm sorry. That was a waste of time. Anyway, while we're at it here, might as well show you how I would still tackle this. So this is not a closed curve, right? So we need to close it. Close curve, or rather end points. Let's grab the endpoints and let's just add like a straight line segment. Line between 2 points. This one right here. There we go. And then just join the two curves together. Since this is a straight line, it's going to be like off, but it's going to be like fractions of a millimeter off the center point, I mean. So we don't care. Now, since this curve join is actually a closed curve, now area will work for sure. Yeah, there we go. And it gives us that little point right there that we need to get out, and we get it out by just selecting the node and pressing the insert key, or right click bake, whichever you want to do, right? After this is done, I'm just gonna get rid of all of it. We have that little point there, which was me wasting time. Again, sorry about that. And we're just going to take that point and move it very precisely along the x-axis to somewhere here, right? As our reference point. We could have used like the center snapping here, but I honestly, well, let me show you. The center snapping, if I turn on object snap, center snap, and then I don't even remember if it's gonna work. Let's try, select this, M, enter. Okay, so we are snapping to the center of this circle here, and we're gonna be moving it to this point right here. Make sure that point snap is turned on. And yeah, that kind of works, but the more you work, like I always have center snapping turned off, and I try not to use it as much, because in this case, as we're working with a single arm, or not even an arm, like two segments of an arm, there's not a lot of geometry. But when you have a lot of geometry and you have center snapping turned on, and most of your geometry are cylinders, you are not gonna have a fun time. That's why I tend to create these kind of guide points instead of using and trying to snap to centers of different things. Sorry for the tangent. Okay, we're back. So with this object now definitely centered along the axis of the not forearm, bicep, I guess, we will move it in just slightly, something like that. Control Shift, scale it to whatever position we want. Perhaps it could be smaller, so Shift scale. Its center point is on the axis, so we can scale it non-uniformly quite easily. That's fine. And we have ourselves like a little piece. And now I'm just going to scale it down a bit, extend it like so. Maybe like that. Okay, so now it's time to do some, sorry, unlock some unification or merging of the shapes. Boolean union, these two get merged because as this one is going to be rotating, it's going to be rotating around this point, so it's like a part of the shape. And we can use kind of this to make some, you know, make it a little bit nicer. Boolean union or Boolean difference between these two. We get a little disk going on in here. If you want to, you can always select a surface, a cylinder surface, type in dupe edge. God damn it. Select a surface, type in dupe border, not edge, dupe border. Offset the border by however you want, how much you want, like 20, no, 10. Yeah, sure, 10. And then just extrude it out to get a cylinder that you can use to trim away the inner one, or even better, cap, Boolean difference away. There we go. We have ourselves a little bit of a like an empty negative space here. And that's mostly it. That's mostly how you work with this kind of stuff. Of course, you still, you know, as you're doing this, you will start noticing that, oh, okay, if I were to take this, 1 second, shaded view. If I were to take this forearm and I would like to bend it 90 degrees, this is, by the way, important. Those of you who dozed off, listen in. You need to make sure that your objects, as they're going to rotate, will not self-intersect. What I mean by that is, if I have this forearm and I want to have the freedom of 90 degrees, I need to make sure that as it's bent, there's nothing here that would mess up the intersection of it, right? And in this case, there is. So what I'm what I would do then would be take a line tool, for instance. I could take a line tool, I could take a curve tool. In this case, I'm gonna take a line tool like so. And then I would perhaps do something like that. Fillet edge or fillet corner, I'm sorry, fillet corners. How much? Like 5 centimeters, 50 millimeters, something like, oh, no, like 10 centimeters. Yeah, that's much better. Like a pretty sharp fillet. Make sure that it's a closed shape. So I'm just gonna do this kind of weird polyline here and join it into the part that actually will do the cutting. Then go back in here and just trim away, let's say just this portion, right? Something like that. Right? And then I do Boolean difference. Oh, sorry, cap. You select this, you type in cap to make it closed. And then you do Boolean difference. From this, enter with this, enter, delete this, delete the trimming form, and you get this. So this is like half of the, actually, I kind of want it to be a little bit wider. There we go. So this is like half of the solution, because the other half will be, let's rotate again, 90. You see that here in the middle, it's, actually it's not, it's even here, it's pretty bad. So we will need to go back to it and make it a little bit more aggressive, or we can solve the remainder of the problem by trimming out the areas for the forearm so that it kind of bends in place and it doesn't intersect. So let's do it that way. I guess we can keep it, edit, redo. We can keep it here and just draw out the Boolean solution in the side view. So that needs to be something like so. Perhaps like that. If you want to deal with like 45-degree angles and work with that, you can always right click on the ortho right here where it says ortho, right click, set ortho angle, and you can set it to 45 degrees. And now as your ortho is turned on, it will snap to 45-degree angles. Some students like that. So we can do this, oops, like that. Let's just be brave. Let's just drag it out all the way to here and get it going there. Fillet corners, 10, sure. And then, wait, yeah, that's fine. And then close curve, like that. And we can, honestly, for this thing, we can just drag it all the way out. Cap. And let's go for Boolean difference with this shape. There we go. So now there is no intersection as this is being rotated 90 degrees. If you want an even, oops, here, if you want an even more aggressive rotation, then there needs to be even more negative kind of form, negative space that's made for the shape, right? Anyway, let's put it back in place where we want it, and this is how it looks like, right? So you might argue that this is not, this area is not great, and then you work more on that area, and then that area is not great. But since we don't have the time, And I have shown you the the principles of this kind of a form creation. We should move on to the next step. Let's unlock. And the next step is retopology of this particular form. Yes, retopologizing, retopologizing, I think that's the correct term of saying it, of these kind of shapes is done exactly as how I showed you it being done with the Revit model, with the Blender model. And 1 second, I have it here. Just give me a second. And there is one little thing that I really would like to kind of get your attention on. And that is when I was doing the CRT project, I would first create, these kind of shapes. So let's open it up for me to show you. I would first create these kind of shapes and I would create them in NURBS. And you can see here that this is not perfectly sharp, right? It's filleted. So I would fillet them. This is, yeah, there we go. So these fillets. This is something that you should not do if you're planning on retopoing your geometry, right? Because when you're creating fillets right here, like so, those fillets will be a pain to later take in and try to try to get the correct angle at, right? Because everything is rounded, so you don't really know what to attach yourself to or what to create the rectangles or sub D quads onto, right? Because everything is smooth and everything is rounded. So that was a pain in the ass. This is much better where things are sharp, and when you're doing 3D face, sub D. Let's very quickly just show you sub D. Let's just start from here. Bam, like that, and just snapping to the forms like so helps you so much. Well, if you're able to snap. Okay, let's try again. Oh yeah, that's the center point snap. Most likely that was messing me up. Let's try again. Yeah, okay. Now that works. Right, so we are just kind of creating the topo here much faster because we don't need to. Well, in this case, it's gonna be a little bit of a problem. But oh, actually, this brings me to an important note. When we were dealing with a mesh, using sub-D retopology tools was pretty easy in a sense that we had so many points, like vertices of the mesh to snap onto. So we would kind of select any point that we want to snap onto. When we're dealing with a mesh, with a NURBS geometry like this, you can't really snap onto the middle of the surface. You always need to snap to the edge. And we can do it this way, but there is one more step that needs to be done then once you're done. And that step is taking this geometry, right? Because now you can't take this point and, connect it with anything else because there's nothing else. So you do need to insert edge from here to here, let's say, and insert edge from here to here to basically get the correct amount of vertices all the time along the form. I'll just stitch them together like so. Stitch these two bad boys together like so. And I can see here that my aim is not the best today. It is what it is. We stitch these two together like so. Stitching is merging. You can think of it like 2 points become one, just a very, very good tool for cleanup. And we start getting, you know, the results that we're after. If this happens, yeah, if this happens, that means that your 2 points are like away from each other. They're not a single point. So you just need to Control Shift, drag through the area. 2 vertices were selected. Stitch, not sub-D stitch, just stitch, enter, stitch location, sure, average, that's fine. And now we're fine. Now we're Gucci, right? So you can use that. Since besides this is like all you need to know about retopo in terms of NURBS retopology. We still have 2 hours, huh? We're gonna go a little bit over time. Sorry about that. So I will skip over the retopology in NURBS because it's just a repetition of my previous showcase of retopology, and I'll show you automatic tools of how you can retopo things. So the automatic way is, let me just make a copy of this. Bam. Right? And the automatic way is pretty straightforward. You just select a shape and you type in quad remesh. It's a remesher in Rhino that is actually not that bad. So with quad remesh, you will always end up with more polygons than what you would have if you were using a regular remeshing tool. If you were manually remeshing or retopologizing a mesh. But in this case, let's just try it out. Let's see how it goes. So I will, for now, I'll keep it all as default. I will say that I do want to convert it to sub-D. I do want to preview it. And I do want to hide the input objects. And this is what it gives me. And honestly, I'm not that yeah, I mean, it's a lot of resolution for this type of a shape, but it's not that bad. We could work with this. I will try to see what happens if we decrease the face count to 1,000. Am I smart? Okay, there we go. That was weird. Also, why is this now showing it to me as a mesh? I want it as a sub-D. That is strange. A little bit of a strange behavior. I blame the fact that I updated Rhino. Anyway, I feel like 1,000 quad count. So like we're basically saying, give me like an approximation of this mesh with or of this nerve shape with 1,000 quads or 1,000 faces, and it's doing it. And the faces can change their size by like the strength of that effect is 50%. And we do want it to use this hard surface edges to find the flow of the quads. So we're saying just be smart about it. And yeah, hitting preview, hide. Yeah, we can delete the input objects. Don't make sure that convert to sub-D is turned on. You don't care about sub-D creases, corners, or interpolated sub-D. Definitely not interpolated sub-D. Hit OK. And we do this again, I guess, because it doesn't want to work with us. Try again. Preview. Okay. please. Okay, it doesn't want to give us a remeshed shape, of course. This is, by the way, the first time that I see it doing this, so that's always fun. Let's go for a little bit more for giving quad count. Let's go for 1200. Hide, delete, okay. Right. So it has problems. It has issues with remeshing a few areas here and there, but I feel like we can, we can squeeze by. We can do this manually. That's fine. We'll fix this. So let's do the other one as well. Preview, hide. How does this look like? That looks fine. Okay, so this one is better. Just hit OK. And let's just bring these two back on top of this initial original NURBS shape. So I'm just going to say move enter from the corner point here to the corner point here. There we go. Now I will select cell NURBS, or sorry, cell poly surface, poly SRF. Lock those, and wherever I have, and also make sure that it's the correct layer, and wherever I have like these weird issues, weird behavior, I will try my best to fix it. So first of all, this, select the shape, append face from edge. Yo, you wanna give me the edge, please? Oh, this is very broken. Oh no. Oh no. Okay, let's see. Let's see. So first of all, that hole right there is not great. So this one we can very easily fix by just selecting these two edges and typing in bridge. That's it. That's fixed. This one we can't fix that easily. At least I don't feel like we can, because it made a mistake here, right? So this needs to be like a triangle. I will not use append because that seems to be bugging out and freaking out like crazy. I will just use subd tools, and I will just create a single subd face right here. That is gonna be a triangle. Perfect. Then hitting enter, I will repeat the tool and I'll create another quad here. So slowly we're basically just gonna build up the whole thing. That's gonna be a quad. We're gonna just stitch this whole thing together. A quad here. That is a quad, triangle, a triangle. So quad remesh really doesn't like triangles. I don't think it's even capable of adding triangles. I think that's why it struggled so much with this particular area. What? Can I please snap to? Okay, there we go. No, we don't. No, we don't go. Anyway. And I think from here we just, yeah, that's gonna be one more triangle right there. And from here we just need to bridge these two. Oh wait, this is not an open edge. Okay. I think this is a chance for me to show you a cleanup way, like how you can clean things up, because unfortunately automatic tools that I wanted to showcase just shat the bed, so we need to mop it all up. When we have a messed up mesh, we type in Grasshopper. We type in Grasshopper, and we type in subd, we reference in the subd geometry right here. We extract subd control polygon, control polygon. We get the control polygon. So now we're dealing with a mesh. Then we get the best tool out there, which is, wait, is it in pufferfish or is it in kangaroo? Cleanup, combine and clean, there we go, combine and clean, which basically removes all of the duplicate vertices of the mesh. So if I'm not mistaken, here we have 925 vertices. I'm not sure if you can see it. Maybe it's a little bit, the text is a little bit too small. 925 vertices. Here we have 914 vertices, right? So it's basically removing stuff and cleaning things up, but it is a mesh. So now we need to convert it back into subd and bake it out, right? And while I'm doing it, I will lock this subd so that it's, you know, we will know which one is which. To do this, we will go to surface, subd from mesh right here, and just connect it like that. And this should be more than enough to fix like 90% of the issues. So I'm just going to insert it. If it's not gonna work, we're just gonna reuse it. Sorry, we're just going to redo the retopology. I'm just gonna create a new layer, call it clean, make it like a orange or something, change object layer, and see that it's still messed up. Oh no. Oh no. Second. Maybe it's gonna work. Maybe it's gonna work. So let's take this, our subd here. Let's join it up. We're not joined. Okay, it's just going downhill from here. it's all downhill. Let's delete that. Unlock, and let's just remesh everything in with higher values. Technically, you could also use align vertices and try to get rid of duplicate vertices that way. But honestly, if the combine and clean doesn't fix it, align vertices probably will not be able to fix it as well. So instead, we just we just unlock. There we go. Quad remesh this properly with higher values. Target. Let's try 1500. Yeah, that seems like it's remeshing fine. It is what it is. And we just hit OK. Okay, so now with the two subds done here, you could kind of go through the edges and sharpen them. Remember when I showed you how you can show you on this side right here, like that. When you double click, it gives you the full-on ribbon, right, of that side. And then just typing in insert edge. No, sorry, inset. Typing in inset, doing it as a group, and then choosing, let's say 0.5 millimeters, like half a millimeter. Hitting tab, you can see how much sharper this area is compared to this one. Let me show you with EMAP, even better. I prefer using fluorescent tube, right? So here, super soft, right? Super soft transitions. And here it's like laser, sharp, sharp. So insetting works also. If you don't want to use inset, you can always use, I'm just Control Z'd it. So now it's soft again. You can always kind of select the form, let's say this one, and do bevel. 0.5. And you know that is going to sharpen things as well for you. But be mindful of creating pentagons. When you're doing a bevel, you're basically taking the ends of the bevel and saying that that's going to be, that becomes an edge, right? So when you're creating edges somewhere, in this case here, as well as here, oh, that was a triangle, so it became it became a quad. So it's only here that you're creating a pentagon. So you would need to delete this and then say bridge that, fill that, and now it's, you know, a triangle that eats up, and now you have a sharp corner there, right? So that helps. That is not nice. 1 second. It keeps making that that error there. Okay, this is a closed sub-D, this is a closed sub-D, we can move on. So now in terms of getting this in Blender and retopoing in Blender. Sorry, not Ripto, what am I saying? I'm getting tired, am I not? Adding textures, unwrapping, UV unwrapping this in Blender. That's the next step. Let's do, how much time do we need? Like 3 minutes. 3 minutes, and then we'll continue. So a small break, just 3 minutes. Pee, drink water. We don't need to end at like 5-hour mark sharp, do we? We can go a little bit extra. Michael, if you're listening. Oh yeah, sure. I can share the Rhino file. And there we go. The ARM 3D model is on the chat, in the chat. Oh no, I'm out of coffee. 1 second. I'm back. So let's continue. Coffee goes here, or rather, coffee goes into me. Okay, so Rhino part is mostly done. We don't really need Rhino, at least at this stage, anymore, except for exporting this sub-D model as a mesh into Blender. So I will just select both of these forms, type in Grasshopper. Let's delete everything here. And I will reference both of these as sub-D because I want to create a cage, a mesh cage from these sub-D forms. Those are gonna be the ones that we export. So I will reference in sub-D, right click, set multiple sub-Ds. There we go. We're golden. They're linked now. And to get the cage, all I need to do is do the, actually I already showed you this, sub-D control polygon. That's the name of the node. Bam. I just select this node, right click on it, choose to bake, and I bake it into, doesn't matter, layer 01, hit OK. And now we have ourselves a mesh, or rather two meshes. I actually don't need them to be, and they will not look nice. Trust me, they will look pretty bad, but that's fine. That's okay. So with these meshes, we will just join them up into one, or you can export them as separate meshes and join them in Blender. Maybe it's even better if you join them in Blender. Yeah, let's export them as separate meshes. We will join them in Blender. So don't join them. Close that. Select the form. How's the topology here? The topology is good. Okay. Because we need to know at least one, not corner point. How do you call it? Middle point of the form, but since we will be able to fish it out, that's fine. We select this, type in export. You just need to select just the mesh. You don't need to select the sub-D, and we will export this as a OBJ file. You can do FBX, OBJ, whichever you want. For some reason, between Rhino and Blender, I use OBJ all the time, even though FBX might probably be better, but I never had problems with OBJ, except finding them. There we go, OBJ. Robo arm showcase. Save. That's it. It's exported. Now in Blender, let's create a new file. File, new, general. No, don't save. Don't need to save anything here. We always do this. A, delete. Delete. Fresh, completely fresh file. Nothing inside here whatsoever. File, import, OBJ. Navigate to our little file that we have just made. There we go, import. And it's gonna be somewhere. It imported really big and the range of the view is not great. So we need to fix a lot of things now to make this work. So the first thing that we need to tackle or work on is the scale of the object. It's huge, it's humongous. And the reason for that is we worked in millimeters, Blender uses meters, so it's all scaled up a lot, 1,000 times, and blah, blah, blah. You need to go to the scene settings, and under units, we stick to metric units. So we stick to meters, that's fine. but unit scale, we want this to be 0.01 meters. Enter. So it's as if we're dealing with this in centimeters. Yes, as if we're dealing with this in centimeters. The reason for that is because Unreal Engine uses centimeters. You might ask, why the hell are we not just changing this to centimeters and then calling it a day? Well, that would be the easy way. No, in all fairness, there is some sort of a bug or an issue where the collision for Unreal Engine does not calculate properly if you are exporting in centimeters. So it's better to export FBX files. So it's better to export in meters and then have it kind of scaled down 100 times to a centimeter range. Don't worry about it, follow along. Then this object right here, that's still outside of our view range, which is a little bit annoying. Press the N button. Oh, and one thing, just bear with me. Now you will see what I'm pressing here in the bottom. So press the N button. That opens up this menu box here, right? And in this menu box, we will go to View, and we will say that our clip end should be bigger than 10 meters, right? Because now it's kind of clipping the view 10 meters away from the camera. So let's just increase it to 100 meters and that should fix it. There we go. There's our little, ew, disgusting. There's our little arm, right? Now, in terms of the size, you always need to make sure that you're kind of not messing things up. So let's just take the measuring tool, the whatever it's called, tape measure tool, I guess, and just measure the length of the arm to see, to see how long it actually is. And it's 12 meters long. I don't think it should be 12 meters long. I think it should be 1.2 meters long, right? So what we need to do is we need to scale this arm by 0.1. Again, the logic is this. We modeled it in millimeters. Blender uses meters. So millimeters directly got translated into meters. So everything is 1,000 times bigger. Then under units, we scaled everything down to be as if it's in centimeters, 100 times lower. 1,000 times bigger arm got scaled down to be 1,000 times bigger arm got scaled down to be 100 times smaller. So it's still 10 times too big. So we need to scale it. Select the arm, type in S, and type in 0.1. Enter. No need to the enter. Oops. You press enter only once, right at the end. Now it's smaller. The problem with Blender, or rather, it's not a problem, it's a feature. A feature of Blender is that it remembers the scaling factors of different things. So if I press N here under item, I can see that it remembers that for some reason the arm was rotated 90 degrees in X direction. I guess that's the OBJ import options. And also that it got scaled down by 0.1, right? So it's 10 times smaller. We will need to fix this, but before we do that, we need to center the arm to be, properly placed in the world 000. I should have done this before exporting, but now we can do it as well. That's fine. So I'm just gonna select the arm, right? Selecting the arm, pressing Tab. Tab gives you edit mode, where you can mess around with the vertices and so on. We will not do that, but you press Tab. Now you're in edit mode. We press 2 on our keyboards, 2. That gives you edge editing mode. 1 is vertex, 2 is edge, 3 is polygon, polygon editing mode. So 2 for edges. Holding the Alt key, I really hope that I remember this correctly. Holding the Alt key, we will just click on the outer ring, outer edge here. And that gives us the outer loop for this whole arm, right? Like that. And now we want to get this little doohickey here, right? And we want to center it onto the arm, or sorry, center it onto the ring. So I'll say Shift S, cursor to selected, Shift S, and then cursor to selected, the option in the bottom. Click that. And now our marker is right in the, right in here, right? Positioned here. Which means that now I should be able to, give me 1 second. Origin. Yes, perfect. Okay, so then you press tab again to get rid of the edit mode, right? You're back in the object mode. Your marker is here. Then for this object, you go for object, set origin to 3D cursor. And now your, like the center of mass or the origin of your robot arm is right on this point, right on here, right? And then you can just say Shift S, cursor to world origin, right? And then that's that. Oh yeah, and you kind of need to position this, but now positioning it is pretty easy. You just select this arm right now. Since its origin is now placed here, all you need to do is within the N menu under item, here you just say 0, 0, 0. You zero everything out. And you're good to go. You're good to go. Okay, so I'm thinking, do we want it to be vertical when we're animating it or horizontal? Maybe horizontal. Let's keep it horizontal. So now I'm going to apply all of the transformations that were done to this arm. So for instance, the rotation, this rotation right here, and I'll apply the scale. You do this by selecting the arm, Control A, and choosing all transforms. So apply all transforms, bam. Now you can see that everything is like, there's no rotation, there's no scale. Like this is the object at its origin and it doesn't have anything applied to it. Okay, now let's apply stuff to it. First of all, let's make it less ugly by giving it a modifier. So modifier, the little wrench icon, add modifier, Catmull Clark, subdivision. All right, subdivision surface, sorry. We click that. There we go. And now it's getting back to the original kind of look, what it had, right? So that's level 1, and we can switch to viewport shading to be wires if you want to, but this is actually good enough. Level 1, I think level 2 is gonna be good enough. Let's turn off the statistics. 78,000 polygons. I would scream if I saw this in a character just for one arm, not even without fingers, just 2 parts of an arm. But as a showcase, that's fine. It is what it is. It's okay. Right. Now we need to save this. And I will call this final arm showcase. It's gonna be important. And just in case, you know, it breaks and so on, we will have it going. And now I am going to create armature for this arm. Wait, are we being idiots? This needs to be disconnected, doesn't it? That's fine. It can rotate around here, I guess. So it's kind of gonna be an awkward connection here, but oh, that's fine. That's actually fine. We can, if you want to, we can add more stuff to this to make it a little bit better, because I made like a design mistake, design mistake here. For instance, here we can add like a box or something here, that the arm is actually, how do you call this, hand? We can add the hand to the end to get even more articulation. I guess maybe that would be pretty cool. So let's just add at the end like a little box. So I'll show you how you can easily attach stuff. Shift A, or yes, Shift A, mesh, and just choose whatever you want for the end. I'll just create a cylinder here. Scale it down quite a bit. Oh, S, no need to press enter or anything. You just scale it. Then R to rotate it, Y to lock the rotation to only the Y angle, or sorry, Y axis, and press, type in 90, hit enter. So now it's scaled and rotated 90 degrees. G to grab, I guess it's grab. G, X to move it while it's grabbed, and position it, at the end of your arm. Then scale again, just to get SX. Yeah, sure. Something like that. Right? And then let's just do another one on the other side right here in this area. So I'm going to, so while this one is the important thing because it's a socket for the shoulder, let's do one more. G, no, sorry, Shift D to duplicate, Shift D, X, and just drag it to the start of your arm. And then, with scaling and so on, we just make it nice. Okay, that's fine. Oh, and don't worry about the the resolution or the materials or anything like that. It's not a big deal. We would just be modeling these things in Rhino either way, but here it's just faster to add them in Blender. So to add objects to an existing object, you just select the initial object, the arm, holding the Shift key. You select the two extra objects and you type in, not type in, but do J, I think. No, Control J. It was my bad. You do Control J. That was a mistake, wasn't it? Because now it inherits the center point, the center of mass of the last object you have selected. So Control Z, and let's undo, and this time let's select first cylinder, second cylinder, and then the arm, and Control J again. Yes, and now it works. Now it works. Kind of works because it's now applying the subdivision to the cylinders as well, which we shouldn't be applying subdivision to those. So I'm sorry. Again, Control Z, undo. Let's apply the subdivision to the arm, and I will just decrease the levels to 1. Apply. And now, so cylinder, arm, Control J, god damn it. There we go, finally. Now we have it. Now we have it going. Okay. So now, we will create the bone structure for this thing. So I will do Control A, armature, single bone. 1 second. Yeah, that's fine. Control A, armature, single bone. Hope everyone has that. It just creates this little bone right here, right at this location. And I will hit tab. And let's zoom into it. Yeah, there's our little bone, right? I'll hit tab and I will just rotate. Is it possible to, 1 second? Yeah, it's gonna be fine. So I will not be rotating it. My apologies. I will just hitting tab. I will select the top of this bone. Here I will select the movement tool, the move tool, and I will position the bone. I'll just move the bone until it's going to reach here, the middle here. And you could be very accurate about this, by the way. So if you want this centerpiece or the end of the bone to be precisely located, let me move it up actually. To be precisely located at the center of this ring, you could do that by just holding, selecting the robot arm, hitting the Alt key or selecting the Alt key, and clicking the one of these kind of edge loops, so that Alt key basically selects the whole edge loop, right? Then Shift S, cursor is selected, so it gives you the little 3D cursor right in the middle of this circle, right? Then tabbing out, selecting the bone, hitting tab again to get into edit mode, selecting the end of the bone, Shift S, selection to cursor, and just plop, snaps it right in, right? So that's how you can do it. Then for this, I will just extrude the bone, another bone for the, forgot the name of this part, forearm, for the forearm of our robot. Extrude. And we need to lock to X axis actually, like that. Something like that. And here it doesn't really matter because this is disconnected and it's just gonna flop around either way, like this cylinder. So we don't really need this to be super accurate, but we do need this to be locked to X axis perfectly, right? As well as we possibly can. For some reason there's a twist there, but we will figure it out as we will go along. And then the last one, again, I select the end of the next bone, I type in E, extrude it even more, and we have the last bone. If you have troubles with seeing bones, like these bones in the form, and in the structure, you can always go for bone property, armature, viewport display, and here you can choose in front. So you need to select the whole armature here, viewport display, in front. And now the bones will be shown right at, right in front of your form, no matter the angle. It gets a little bit annoying, but it's important. And while we're at it, axis, this one should also be tick marked so that you know which axis you need to lock onto, and if things are aligned or not. And here I can see that things are not aligned because the Z axis is not parallel to the cylinder that I have here. So I will go back in here. Sorry, not in here. And I will try to fish out where I can change the properties of the bones. Or not the properties, but the rotation values of the bones. I believe it's under pose. That's rotation. 1 second. If that will not work, we will need to redo the bones, but that's fine. I will do them really quickly. So that is not going to take too long because, yeah, the problem that we have now is that the bone, as it is right now, you can see that the bone is rotated, right? It's twisted, and we cannot have that. We cannot have that happening. So I need to figure out why is it being twisted. Always a pleasure. That's a radius, that's a roll. The roll needs to be 0, doesn't it? Perfect. Okay, so the way you need to do this is, let's go back to standard. Okay, now I don't have anything selected and I am in the object mode. You need to select your bones. You go to edit mode or press tab and you select you know, a bone that is misaligned, that's misbehaving. In this case, it's literally every bone that we have. And you adjust, you press N to open up the item menu here, and you adjust its roll right here, roll. You do 0. And now it's aligned perfectly. Now next bone here, roll 0. Aligned perfectly. So you don't want any roll in the bones. And this one doesn't matter, but I'll still do it. Roll 0. Okay. We have ourselves three bones right here. Right? Okay. So now, technically it should be 4, shouldn't it? Because according to this, there needs to be like, okay, extrude X. There's kind of one more bone just sticking out there awkwardly. Because the main relation is this, and this one just kind of eats it up, which is fine. But the main socket is gonna be like this bone right here. All right, so with this done, we need to now actually use these bones. And the way, by the way, the way you can see the relationship between the bones is by going to selecting the, damn it, going to object mode, I believe. No, going to pose mode, selecting the bones, going to pose mode. And here under animation, under not animation, I'm being stupid. There we go, under tool, we will have auto IK. So if you tick mark this and then you select one of the bones, you can see that it's, and press G, sorry, press G, you can see how the bones are trying to facilitate the movement of one of them, right? So that's IK chain that's doing this. And you can see that this bone is not not like a main one, so it has its own little life, but that's okay with us. All right, so now let's undo. Auto IK is selected, that's great. Now in terms of the bone behavior, there are a few things that we need to discuss. First thing is you can't really have this bone rotating weirdly because we have very, very strict restriction how this arm can rotate. It can only rotate around which axis? Around x-axis. It can't rotate around z or y-axis. So it can't roll. It can only, do this. That's about it. So we need to apply restrictions to certain bones. So this bone right here, we know for a fact that it can't rotate. So I will select this bone. We are in pose mode, by the way, important. We are in pose mode, and I will apply a constraint. Okay, so this will save you a lot of trouble. Listen up. There are two ways or two options for constraints. There are object constraints, which have, by the way, if add object constraint, it has limit rotation. And there is, only when you're in pose mode and when you have a bone selected, there is bone constraint. If you do object constraint, it will not work. You're gonna have a bad time. You're gonna spend hours figuring out why doesn't it work. You need to apply, when doing robotics, you need to apply bone constraints, right? Add bone constraint, limit rotation. Now this turns green, that's a good sign. And you specify which rotations do you want to limit. We want to actually limit all of them, X, Y, and Z. It's going to freak out like crazy. That's fine. So once you've limited all of them, you're basically locking it into 0, 0, 0 value, right? Because you're limiting the rotations. Right now, the bone kind of thinks that it has rotations according to the world. That's because the owner of the bone is world space. No. The owner of the bone is itself. It's actually local space. So you change world space to local space and you're Gucci. You're good to go, right? And now you will be able to, okay, let me show you. Now, if I just mess around with this and bend it in a weird way, see how that snaps? So it, no matter what I do with this and how much I try to bend this, it's going to snap back to being completely straight. That is because all of the rotations now are set to 0. While I do want them to be 0, from 0 to 0 for Z and Y, for X, I don't want that. I want, for X, I want the rotations to be, okay, so can it bend backwards? Maybe yes. So minimum is like -10. Can it bend forward? Definitely yes. And we designed it so that it can bend 90 degrees. And now if I, let's do this a little bit more scientifically, because not just taking that and just dragging it around weirdly. Let's select this bone and let's choose rotate like that. And here in the top, again, we're not using world XYZ rotations for our gumball, but we are going to be using gimbal rotations for our bone. So gimbal. You could use local as well, but align each axis to the Euler rotation axis as used per input. Yeah, sure. Gimbal. We do that. Now you can see that X actually rotates around X. And now I can do this, but if I try to rotate it in Z, it will not let me, right? It's freaking out. If I try to rotate it in Y, it also doesn't let me. It only lets me rotate in Z, and it only lets me rotate, I can't rotate it more like than 90 degrees. It's freaking out, right? So only that. And then backwards, I can't rotate it more than -10 degrees, which I think is reasonable. All right. Go back. There we go. So this bone is done. I'm gonna do the rest real quickly. I think this one should have full freedom. Well, maybe let's do limit rotation, owner, local space, limit all, but also do like minus 50 to, or 45 to 45 for all. Just so that it doesn't bend into itself. Last one was 40, my bad. Okay, so that's done. Then this one, this should be able to, the problem. So now let's talk about the issues that I've made for myself. The problem is that this should have been like a separate entity in itself as well, so that it could yaw or roll, so that it could twist. But unfortunately, I am an idiot and I merged the disc together with the bicep. Can't blame the software update for that. So instead, we will need to just use this for the yaw. Sorry, for the rotation, which is, I think it's okay. Yeah, it should be okay. So this one, add bone constraint, limit rotation. There we go. Limit X, Y, Z. Again, it's freaking out, right? So we do local space. Perfect. And we will, what do we unlock? So for sure, it can rotate around the y-axis, right? And it's like full on 180 degree, or sorry, 360 degree rotation. So we don't tick the y-axis, so that it's able to basically do this. That. And then for X and Y, I think we can keep it as it is, because we will have that, and it's basically going to be this awkward, super robotic thing. Maybe that's fine. Or we can make it intersect and call that a day. Okay, sure. Let's give it like a little bit of freedom, like 10 degrees and minus 10. Or sorry, minus 10 degrees and 10, like that. Minus 10 and 10 for both Z. So something like this. And for X, like that. Okay, so that's our bone rig, kind of ready to take part and then transform the actual arm. So we're gonna go back to object mode, drink some coffee. Okay. In object mode, we want to now parent the bones to the body, to the, in this case, to the arm. The way we do that is we select the arm, we select, holding the shift key, sorry, we select the bones, holding the shift key, we select the arm, and I really hope that I'm doing this in the correct order. Control P. Okay, never mind. You first select the arm, shift, select the bones, Control P, and here you need to select with empty groups. Let's talk about this for a second, because this is important as well. There are two main ways of how you can apply the armature, which is a skeleton, to any form: with empty groups or with automatic weights. Automatic weights is used for soft body armatures. soft body meaning like humans, animals, and so on. That's automatic weights. That means that your mesh is going to be transitioning, like the formation of your mesh is going to be more of a gradient and less of a, this part belongs to this bone and it doesn't deform at all. There's no stretchy bits whatsoever. Everything just moves together with the bone, right? That is the with empty groups when you want like a fully robotic thing, like hard surface thing. So in this case, we're using with empty groups. I don't feel like I've explained this well enough, so I'm going to create a new Blender file just really quickly to iterate it. Okay, while this is loading, I don't know why, but my Blender is like, it takes forever to load in. While that's loading, I can show you how this works. Right now, every bone, first of all, every bone has a name, right? So the naming convention, or not convention, but the way Blender names the bones is bone. Then the next one that you create, bone 1, bone 2, and this is going to be bone 3, right? Bone 1, bone 2, bone 3. Usually you want to name them a little bit differently, but it is what it is. You can see that now these are two parented into one kind of group. And if now I go to pose mode and I take the last bone and I start kind of messing around with it, you can see that the arm doesn't care. It doesn't, nothing happens, right? And the reason for that is because I'm back in object mode. The reason for that is because the bones have empty envelopes, so to say, so they don't really control anything, right? There is no relation still between the mesh and the bones. You know that the mesh, the bones belong to the mesh, but they don't influence the mesh because every bone doesn't know what to influence. So what we do, or what I do, is I go to this shape, the bone shape. Sorry, not the bone, the arm shape. I select that. I hit tab to edit, enter the edit mode. You can see here. And then I need to, oops. And then I need to apply certain parts of my mesh to certain bones. So I will navigate here. Was it here? No, it wasn't here. Give me a second. Yeah, it was here. Object data properties. You navigate to here where you see bone 01, 02, 03, as I said. And these are basically empty bone groups. So those, again, this is bone 01, bone 02, bone 03. And these bones are waiting for, okay, so what are the vertices that we need to move? So we need to give them. For bone vertex group, I will just hover my mouse over the form which I want to apply to my bone vertex group. Hit L key, which basically selects the whole island here, and I will just click on assign. Perfect. Now I know that this part is assigned to bone. Then for bone 01, I will select this one and assign. Bone 02, assign. Bone 03, assign. There we go. Seems like nothing changed, right? But if I go to pose mode, yay, the whole damn thing moves. Great. So now I'm able to pose this, right? This is now posable. So now it's time to create animations, I guess. All right. Now, so for those of you who are who have never opened Unreal Engine before, I suggest that yeah, we should jump into Unreal Engine and actually open it up. And I will save this file. Oh, actually, before I do, I will set it up for you so that you can follow along quite easily. So let me just create a new window here. Make this into a NLA strip. There we go. That's great. Then go in here and create, or rather, let's change the timeline. So here you can change. This is like where the animation plays, right? The timeline. You can change how long it is, and you should. So in our case, we will just do like, let's go for 4 seconds. Yeah, 4 seconds. So 4 seconds times 30, 120, right? 120 frames, not more than that. So we will have animation loops that go for 120 frames. All right. And I will switch this into dope sheet. No, I'm stupid, not dope sheet. What's the timeline? No, timeline is doing that. 1 second. No, it needs to be dope sheet. Yeah, that's fine. That's fine. Okay, so we will have it set up like that. And one last thing is it's not gonna be smooth transition between keyframes, or rather maybe it should be smooth, the fall off, because we will need like the start and the end transitions to be pretty sharp for it to loop properly. I'm going too deep into this. Sorry about that. I will save this and send it over to you. Okay, 1 hour, huh? And then we will do Unreal stuff and also animation. That final arm showcase Blender. There we go. All right, great. So now we have, I have sent you the file. Open it up. While you're doing that, I will also talk a little bit about Unreal Engine. So when you're creating like a new project in Unreal Engine, I would suggest that if you're fresh, I would suggest opening up like example projects first. There are in the Unreal Marketplace, you will find quite a few example projects. Just seeing, you know, the anatomy of an Unreal project. This webinar does not cover, you know, that portion, so I'm not gonna talk about it as much. But basically, here you launch Unreal Engine. In this case, I'm using 5.1 because naturally I needed to upgrade it right before the freaking webinar. This is the part that I'm scared of the most, is the not knowing if it's going to work exactly the same way as how 5.0 worked. We'll see. And as it loads in, there we go. As it loads in, it shows you, you know, all of your files that you should work on, or you can create a new project, right? So make sure that your, let's say, games, third person, quality maximum, ray tracing on, and in our case, we don't do starter content. We don't need the starter content. We want to keep it as lightweight as possible, right? So we keep it without starter content. We will also use blueprints, not really, but you should have this enabled. Project name, best webinar ever, and then blah, blah, blah. And then wherever you want the project to be, you type in the location here. You click create, and then you let the computer generate the world for you. I have already done that because I didn't want to wait this time. So I'm just gonna open up mine, but it's gonna be the same, the same file for both of us. Let's just wait for it to do the thing. So we have Unreal as well as Blender, both of them open. And while we're doing that, let me check my notes and see if I missed anything. Yeah, I said everything I want to. Good. So that's our Unreal map. This is a testing map for Unreal Engine. If you press the play button here, you see your little character. You can move around, jump on things. It showcases the physics, and so on. We don't care about that. What we care about is getting our arm, first of all, animated. Second of all, imported into Unreal Engine. So back to Blender, and in your case, it's going to kind of go through shaders and so on, just kind of baking stuff out, making sure that everything runs. Back in Blender, right here. This reminds me, I was talking about soft versus hard surface animations, right? So I just wanted to show you the soft surface animation and how that works. So this is the bunny rabbit that I've made and that I've animated. So this is its falling animation right here, and you can see that it's not great. it's pretty messed up, and that is because of, first of all, lack of my skill in terms of how the mesh behaves with the bones. Second of all, just the bones themselves. This model was not great for transforming. But the thing is, if I go to object mode and we just select the bunny rabbit here, you can see that there are no joints between the different portions, and also notice how low of a resolution model it is. But there are no joints or between the different portions of the bones, right, of the body. Everything is still like everything needs to deform to have like proper animation transitions. So that was this is like when you apply the bones with automatic weights and then you do some weight painting. I think I would be able to weight paint. Yeah, there we go. So this is like, for instance, the shin bone, right? And this is the influence area of the shin bone. And then we have another, like the secondary shin bone, and then you have the foot, like the effect on the foot, on the toe, on the shoulder, and so on. So you can see that everything is super soft, like the transitions are super soft. And this makes it so that when we are looking at the animations, maybe climbing animation is not the best. Falling. Let's go for walking animation. Something a little bit more simple. You can see that how this transforms, and also just so that you don't feel like this is complete garbage, subdivision surface, we do apply subdivision surface to this mesh. Oh, I think we first need to subdivide it and then animate it. No, never mind. Okay, so this is lagging. This is lagging quite a bit, so I can't show it to you subdivided, but of course the final bunny rabbit was indeed subdivided. And then, you know, the bones and so on were applied. But yeah, basically that's the soft body version. Hard surface version, hard body version is this, right? Where every bone controls its own part and nothing else, right? So there are no gradients, it's all super solid and all very kind of defined. So let's create some animations. I hope all of you, or those of you who are following, have opened this file. I believe it's not a dope sheet though. So here in the bottom, I keep trying to create a dope sheet. I think it's an action editor actually. We are going to create actions. So action editor, yes, it was right here, so here on the left hand side, you create, instead of dope sheet, you choose action editor. Got it? Got it. And here you click on the new to create a new action. And you can see that in the NLA, I am not going to explain NLA, we don't have the time. So here where we have all of the list of our actions, basically, you have created a new action that is called action, and you can rename this. So I'm just going to rename this to bendy 1, and you can see it gets renamed here as well. And now we will be applying some sort of a bending animation for the arm, right? So let's say it just goes, sorry. Let's start by locking in this frame. So just select everything. We are in pose mode, by the way. Type in A, or not type in, just click A button to select everything, right? Then press I. I is the insert keyframe. Press I and click on whole character. Bam. You will see here that this little orange dot appears. That is a keyframe. I'm sorry, I'm getting sick apparently. That's great. Whew. So that little keyframe appears, and then we will go through the animation to, let's say, frame 60, and we'll do something with the bones. Let's say this bone right here, let's just rotate it. I use the rotate tool. I prefer using that over just doing, you know, the weird ass grab and then, you know, make the computer figure it out stuff. So I just take this bone and just rotate it. Let's say like so, something like that. Take this bone, rotate it, maybe like that. I don't know what it's trying to do. And maybe take this bone, rotate it around the y-axis like that. And we could, you know, mess around with this, but let's leave it the way it is. Once it's done, A again to select everything, I, whole character. And now you see that as we are going through the slider, with the slider here, it's kind of lifting the arm a bit, right? So now we can, if we still have everything selected, select the keyframe. The keyframe here, just drag around it to make sure that it's yellow. Shift D and just get it into frame 120. Right? Now it's going to be looped. Right? So all you need to do is just duplicate the first frame to the end and it gets looped, right? Then if you want to, you can, at this stage, for instance, you can say, oh, actually, I wanted to take a little bit of a not a detour, but something like this. So I want it to be a little bit different of how it goes down. So maybe we switch it up a bit. Maybe it does that. Maybe here it kind of swivels like that and turns a bit. Doesn't matter. Just a showcase. I whole character. We added one new keyframe, and now you will see that as it's doing that, it's kind of whipping around, like flailing around, right? And we can now change the timing as well by just dragging the keyframes. All right, so that's our first animation. Once this animation is done, we want to, well, not bake it, but save it. We want to save it as an action because currently I believe it's not an action. Push an action down to the NLA stack as a new strip. Okay, so like an action strip, I guess. Don't worry about it. You either click this button right here, push down action, or you click this button right here, push down. They both do the same thing. Bam. As you do this, you can see it generates a strip that is called bendy1 and it's called NLA track. We just double click on this and say bendy track 1, just to keep things in control, right? So that's our bendy motion, right? Now I can easily create a new action here, again, new action, call it zoomies. No, not zoomies, like I don't know, twisty, bendy twisty, right? So here I will just rename it to bendy twisty, and I'm just going to say whole character. I like doing this for looped animations, just kind of immediately shift D, copying it to frame 120 to make sure that you're not at frame 120. G to grab and move it to the correct position, just to make sure that the whole animation is going to be looped, right? That it's going to end where it began. Then saying, let's say at frame 60, this one needs to be rotated 180 degrees. How can we do this? Well, in this case, I can't really use the gimbal, I guess, or the rotation button tool. Instead, I will use R for rotate, and I will use Y as my rotation axis, and I will type in 180, enter. So it rotates around 180 degrees. That's great. I will whole character, and now it kind of does the drilling, like it drills, but it as it's drilling, it goes back, which is not great. That's not what we wanted to do. We wanted to do full 180. So at frame 120, I will select this arm again, R, Y, and this time I'm going to do 360, right? 360. And whole character, wait. Well, that's awkward. Let's see. 113. You can always check when you press the N button. Here, you will always see the transforms that are taking place. And you will see that, okay, it's 1 minus 0, 0, 0. I believe that what it's doing, it's being a smartass, and it's translating my 360 degrees into 0 degrees. So initially what's happening is it's just, you know, I'm just kind of rotating forward and then back to 0 instead of 360. What a smartass. Okay, so instead we're going to say R Y 200 oh sorry 359. Yeah, 359. You could do comma 999, but let's just do 359. Sorry, not Y. I whole character. Are you kidding me? Am I really going to need to troubleshoot this? This is ridiculous. Okay, let's do it this way. I just deleted that whole keyframe and I'm gonna redo it again. What if we do XYZ Euler minus 180? Okay. Minus, is it minus 180? Give me 1 second. I need to figure this out. I think it doesn't recognize Euler rotations. Yeah, because now it's not rotating anymore. So 0 will be true value, and that's minus 180. I'll first do this and then I will explain it properly for you all. Okay. So the reason why it was why I had issues with it turning back was because we were using quaternion rotations, which are like 4-dimensional rotation values that are in between 0 and 1, and it's sorry, minus 1 and 1, and it's a whole mess dealing with quaternions. And if any one of you used KUKA robots or ABB robots, you know exactly what I mean by a whole mess. We're normal people who use normal values, so instead we use Euler angles. And here I just shifted to XYZ Euler values, where I know that all I want to do is just change the freaking Y rotation values of this bone, right? So then I just went to frame 0, made sure that it's at 0, went to frame 60, made sure that it's at minus 180. Actually, it doesn't even need to be here, it doesn't matter. And then switched here to 360 or whatever, minus 360, and just pressed I on top of these values to log them in as my new rotation values for the animation. And now I have like a drilling motion thing. Then bendy twisty. So we did the twisty. Now we need to do the bendy. So at frames 30, I think this bad boy right here does need to bend, and we will just do exactly that. It bends. There we go. And kind of needs to keep being bent until maybe here. So I'm just going to take this, Shift D, duplicate it, and drag it all the way until frame 110, around that. So now let's look. Are you kidding me? Did it just, oh yeah. I can't duplicate it because if I'm duplicating it, it recognizes the the rotation values of this. So basically it re-inherits the rotation values of this bone. I could technically just say expand the summary, and for just bone, I could just delete the angle, the keyframe there, and it should be fine. Yep, that works. Or you could just create a new, completely new keyframe here. Both methods work. There's neither good or bad variations of them. Both are okay to use. Anyway, we have ourselves bendy, twisty, motiony, weird thing here with a little bit of time left. Coffee, good. So now it's time to export things and import them into Unreal Engine. If we will have some time left, I really want to show you the texturing as well, the unwrap. I feel like that's important. That's why I'm kind of speeding up a little bit. So with this new action done, we need to push it into an NLA strip. So again, either this button or this button, push down. We do this. We have bendy twisty, and I call this twisty track. Twisty track. We have two actions, and basically we can now very easily switch between them. And I don't need to see the bones anymore, as prominent as they are. So I can go back to armature, viewport display, and hide bones not to be in front, and hide the axis, and actually even where is it? Instead of octahedral bones, I can do sticks, so that they're almost invisible. Sweet. Okay, now as we play this, that's our animated robot. You can see no distortions, no nothing. Everything moves perfectly. No intersections. Everything is good. Life's good. And then if we want to go for the bendy, you just select this strip, and I'm stupid. You do the little star thing here. You click the star thing, and then it shows you the bendy strip. Yay, the flexing of the arm. Yeah, lifting stuff. So now it's time to get it in Unreal, right? Finally. Okay. Do we do this? I probably should send you the files, shouldn't I? I probably should send you the file. Final arm showcase 2. Save. While I'm doing this, any questions so far, or anything that I might have missed, or anything that you would like me to clarify? Okay. And yet another link that you can download to be able to follow. Everyone sleeping? Do I have a soothing voice? All right, let's continue. One very, very important thing, listen up, important. If during the export, either one of these stars are enabled, tick marked, or whatever you call it, if they are white, you need to click on the star to make sure that it's not freaking white. So this cost me, I'm not lying, a week of trying to figure out why the hell do these exports not work. And apparently they worked. It's just that I had like a freaking star highlighted, and that was yeah, that was it. So make sure that none of these stars are highlighted when you're exporting things. Super important. Okay, or else it's gonna cost you a week. All right. What would you consider is the best route to learn Grasshopper for problem solving in this workflow? I will answer that. I need to make sure that I don't forget to answer. I will answer that after the showcase, because I think it needs to be a little bit more of an extensive answer, and that's gonna break the flow. So if I forget, please remind me about this one, but I'll get to that, and once we have it imported in Unreal. For now, let's do the Unreal bit. So if I have my bones and my mesh and everything, and I want to get them into Unreal Engine, I need to select everything. So select the whole armature. Oh, important. Again, I keep coming up with important things, but this is also important. Armature, this should be actually called root. R-O-O-T, root, like tree root. Let's just say when you grow up and you'll be a big boy or girl, you will want to do some very nice Unreal Engine 5 retargeting action, because you'll figure out that, oh, you don't even need to do skeletons, or sorry, you don't even need to do animations. You can just use the animations from Unreal, and then it won't work, and you will try to figure out why, and then you will remember, oh, I should rename the armature to root, and then it's gonna work. So that's why. For this particular example, it makes no difference. For future, yeah, remember this. It needs to be root. It's just a good thing to have in the back of your head. Anyway, select your root, right click, select, so that, well, wait, no, we need everything to be selected. A, have everything selected, right? In the scene. A, file, export, FBX, not OBJ, FBX, FBX, right? I'll just create a new folder here, just call it exports, just to make it cleaner. And here for the FBX, there are a few things to change, right? So first of all, we don't want to export animations, which is weird. We only want to export the mesh, the skeletal mesh, so that when we import it into Unreal Engine figures out the collisions and so on for the mesh. And once it did that, then we import animations as a separate file. It's kind of breaking down a big task into smaller chunks. That's what I like doing. So for the settings, we don't export empties, we don't export cameras, lamps, we export armature, mesh, and other. So holding down the shift key, I will select other, armature, mesh, other, right? Like that. Then if you have more crap in your scene, you do want to export selected objects, you want to tick mark that. Since we are working pretty cleanly, only have the mesh and its armature, we don't really need to export selected objects. I think I'm, maybe it's fine. It should be somewhere here, right? 1 second. Yes, that's good. I was checking if apply modifiers is an option, because we have subdivision modifier, and I just need to make sure that the subdivisions are applied to the robot arm, and it seems like apply modifiers is turned on, so that's great. Smoothing for normals only is not good when you are exporting for Unreal, because Unreal prefers face smoothing, so we use that. So smoothing, face, like that. Let me check if I didn't miss anything. Do I have my notes somewhere here? Yeah, for armature, right here, you don't want leaf bones. You don't want like additional unnecessary bones. So you remove, add leaf bones. And you want to export only the bones that are deformable. Deformable doesn't necessarily mean stretchy. It means like they can flop around, like the bones that we have. So only deformed bones. So for instance, if you have like what would be a good example? If you have like some sort of an empty or some sort of a controller next to a bone in your Blender file, that when you move the controller, the bone moves, the controller will not be exported. It's only the bone, because that's the only thing that matters. So only the form bones. And then in this case, we don't bake animation. So we untick that and tick that. Don't bake animation, right? This is unticked, important. Don't have it ticked, untick it. Okay, now the name is whatever. Actually, I can just call it arm FBX, export, and it should be good to go. Okay, so now we have it exported. Now back in Unreal Engine, here in the bottom, I will click on content drawer, content drawer, English, and I will just create a new folder. So here we have all of the folders of our I'm brain freezing again. Our projects folders basically are all here. So the whole thing, the whole project is located here. And the main one is called content. So I select that, and here I just create a new folder. So you right click, new folder, and call it ARM. Why not? ARM, there we go. And it asks you to drop files here to import them. So I will navigate to my ARM FBX file and drag and drop it in, just like that. As I'm doing that, it's going to ask me a lot of questions, and I don't know the answers to them. So I will just say, please don't import animations, because currently we're only importing the skeleton. And besides that, if I remember correctly, you don't really need to do anything else. Let me, just so that we're on the same page, let me just make sure, really quickly go through this. That's fine. That's fine. Scale, yeah, that should be fine. Force front x-axis, we don't care. Local, create new materials, sure. Oh, shit, we still haven't even begun with the materials. Invert normal maps, no, don't care. Okay, import all, or import, doesn't matter. Click that. So all I did was import animations. I unticked that, everything else is fine. Hit that. And now in the content browser, you will have the material, you will have the skeletal mesh, the skeleton itself, and the physics asset. If I select the skeleton mesh, you can see the object here. It has shading issues. I will show you how to fix those in just a second. But besides that, it looks fine. Then we, in the top right corner, when we have this opened up, oh, by the way, I opened it up by just double clicking on it. Skeletal mesh, it's also right here, the pink boy. Double click, and then on the right hand side, ARM physics asset, this one. Basically, it seems that it's kind of fine. Should be a bit better though. We'll see. We'll see. Perhaps we'll need to scale it up a bit and fix some importing issues. I am not familiar with this particular type of wait, give me a second. I'm not familiar with this version of Unreal Engine. There might be differences here. Anyway, we close those tabs and we drag the arm in just to see if the scale is correct. The scale seems to be correct. Let's press play. Yeah, there it is. Okay, that's fine. I'll hit delete. And we do need to fix one thing with the arm before we move on, and that is the normals. You can see here, this little disk icon here, that is inverted. We don't want it to be inverted. We need it to be outverted. Oh my God. The shading, it's inside out, right? So that needs to be fixed, but that's very easy to fix. So I will select everything here in the, holding the shift key, in the arm folder, hit delete, force delete, and it's just gone from my project. That's good because I will be re-importing it. So now back in Blender, I select the arm, not the bones, the arm, hit tab, right? So now I have my mesh here, hit A, and then under mesh cleanup, make sure that it's A, so that you have all of the polygons selected with A, or vertices, doesn't matter. Mesh cleanup, it was not cleanup, normals, recalculate outside. This solves the shading issue. Recalculate outside, that's done. Tab again, A to select everything, file, export, FBX, and all you need to do is just select the arm, export, and overwrite it. It just overwrites. Back in Unreal, we drag and drop it in. I really hope that, yeah, that's fine. And now you can see that the shading is works just like we want it to work. Okay, so that's that with the arm. It doesn't have any animation, so we need to export those as well. So here I will file, export, FBX, and we will call it arm animate. Typically you would export each animation separately, but we're gonna be doing all of them at once. Or actually, no, these days you don't export them separately. These days it doesn't really matter. This is old news. You export them all at once. Don't mind what I just said. Under bake animation, now we do tick mark bake animation, but we will expand this, and I believe it's either unticking NLA strips or all action. For sure, we're baking out NLA strips. So you do need to untick all actions. If you bake out the actions, which are, we were creating actions with the keyframes here in the bottom of the view, right? And you are also exporting NLA strips here. Since we created NLA strips from actions, it's going to double. Like all of the imports that you do are going to be doubled, and you don't want that. So we untick all actions. Sampling rate, simplicity, for start, and key all bones, and yep, perfect. I think that's it. We export. Now the animations get exported back in Unreal. We take the exports. Arm animate. We can actually just create a new folder. That's fine as well. Inside of the arm folder, call it animations. You always want to be very, very clean with your like folders and where you place stuff in Unreal Engine, or else it's not gonna be great. So arm animate, drag and drop that in. This time we are not importing the mesh. Untick that. but we are going to select what skeleton are the animations for. That is what we did with our previous import. We imported the skeleton, right? So instead of none, I expand this and I find arm skeleton, like so, arm skeleton. And I believe that's it. Yeah, that should be it. Yeah, so import all. I hated that it closes off. And here we have the two animations. Let's double click one of them. Awesome. It's a twisty boy. It's a twisty boy. So now let's see how you can insert these this model actually in the world, right? So under content browser, arm, let's slap in the arm right here, anywhere. Move it up. And when you have the arm selected, you can, by the way, rotate it as much as you want. So here in the top right corner, the rotation knob right here, you can rotate it 90 degrees, perfect. And yeah, when you have the arm selected, on the right-hand side, you have the properties of the arm model, where you have the animation subtab right under translation, the animation subtab. And here, instead of a blueprint, because blueprint is like just Grasshopper, basically, that's built into Unreal. But instead of blueprint, you might want to use, not might, but you want to use animation asset, because those are the ones that we imported. Use animation asset, animation to play. And we will just choose, instead of none, we will choose bendy twisty, let's say. Why not, right? It will not play here in the preparation mode or whatever it's called, in the viewport. But if we press play this level, and then we figure out where our, oh, there it is, where our arm is, congratulations, now we have a bendy twisty arm. The collisions are not great. I mean, as long as I'm moving, the collisions do register. If I'm standing still, it's just gonna go through, right through me. There are ways of how you can fix this, but it's a little bit out of the range of this course. And I like that the blue is the same as this box. Okay, so that's that's our arm, and of course we can change the from bendy twisty to just bendy. Press play again, and now it's gonna play the second animation here. Let's do something funky with it. And then we will do questions. And no, then I will showcase a really quick texturing like portion, and then we will do questions and answers. So something funky. In content browser, navigate to your third person folder, find blueprints, where you will see blueprint third person character. This is your, you know, like this one, right? The character, right? So you double click it, and by doing so, you basically access the behavior of that character, and not just that, everything about it. So you can mess around with yeah, all sorts of things. Doesn't matter. What matters is what happens in the viewport. So in viewport here, oh, that's my bad. In viewport, you kind of want to add the robotic arm to the character, I assume. You know, why not? Why the hell not? So we're going to be doing exactly that. The viewport tab, this is like the main character, and it's made out of a capsule component, which is basically a collision component. It's made out of camera, which is, you know, the camera for the that's constantly looking at the ass of the character, and it has like a bunch of movement stuff in it, and the mesh itself of the character, as well as a arrow that's showing where the character is looking at. What I want to do is I want to create, so I'm selecting the mesh, and for this mesh, I want to slap on the robot arm, or maybe both, two robot arms that are doing different animations. Why not? So I will do add, and here I will choose that I want to add a skeletal mesh. Skeletal mesh, right? And I'll call it arm 1, arm 1. And it's already, since I have my, I had my mesh character selected, it's already added. If you don't have it added, you just can drag the arm 1 onto the mesh, and it becomes like a child of that mesh. Then we will choose what's the skeletal mesh right here. So make sure that arm 1 is selected. Instead of none, we choose arm. There we go. There's the arm. It currently does nothing. That's boring. That's fine. We will fix it. It should use an animation, right? So we use animation asset here, and we choose that it needs to play arm animate bendy twisty, I guess. Why not? Like that. And now we need to position the arm so that it tracks where the shoulder of this character is. So that is done through parent socket, through here. Parent socket, I click on browse, and then I'll try to find shoulder. It's not called shoulder. Oh no. Is it gonna be upper arm? Wait, give me a second. There's spine, there's foot. These are fingers, middle finger, pinky finger, thumb. So basically you can attach it to anything you want. Let me show you real quickly. Head. Let's attach it to the head. Right? Like that. And now the arm is gonna follow. You know, always be on the head. Twisting and turning. I can turn off the animation for a bit, just so that you see, you know, even without the animation, the arm is kind of following. So now we really want to find upper arm left. Oh yeah, yeah, hell yeah. That's what I want. Perfect. And we just kind of position it like so. Let's give it arm. Oh, sorry. Asset. Twisty bendy. Okay. You can scale it as well. Make it a little bit smaller so that it's not, you know, so that it's not too obnoxious. Something like that. Okay. And then, sorry, blanking out. Oh, then you can change the material for now. We can just use mannequin material because it's going to be a similar one. The tiling, the texturing is not going to be, you know, anything to write home about, but at least, you know, the shininess, the glossiness is going to be similar. You can also kind of just go through these materials, try to find one that fits better. I think maybe Quinn. No. Never mind. Okay, so we do that, and then I am just going to copy and paste arm 2 and drag it on top of the mesh, arm 2, and this time I'm going to socket it to, you guessed it, where's the socket? There we go, to the other arm, upper arm right. like that. Drag it into the correct position. Rotate it correctly. And this one maybe has the bendy, right? All right, that's it. Once you're done, you just compile, close that, or you can save that, close that, press play. And now you have robot arms. Yeah, that don't look that great, but also kind of cool, even without, you know, a bunch of cool textures and whatnot. So honestly, I mean, you can build really weird stuff really quickly and just wrap this whole character around that, you know, robotic weird stuff, and just no one will ever know that there's an actual kind of character behind this, and it's gonna still look natural because you're basically stealing the animation. The underlying animation would be for Unreal engineers. So that's one way to do this. Yeah, I'm just happy that at least this one didn't pose any problems. Okay, I have 5 minutes to do the last bit. Could use those arms. Yeah, same. Honestly, same. Imagine the productivity. The last bit is texturing, or applying texturing to this model. Under edit mode, under edit mode, you want to basically unwrap this with, you know, proper UVs, and you can do this quite easily if I just go to UV editing here. Oh, that's weird. It's already like partially unwrapped. That's funky, but no. You can do select everything, UV, smart UV project, and then call it a day. You hit OK, and it smart UV unwraps. The true way of doing it would be to manually select where the seams are, but unfortunately we don't have, I can't, we don't have the time. It would take me like at least an hour more to do, and I do want to answer questions and so on. So instead we are doing the automatic UV, smart UV project for everything, which basically gives us the nice little islands, not islands, how do you call them? Yeah, islands, UV islands here. And those can be, now as you will be adding textures to this arm, those islands will be super useful because the textures will not stretch as much. With that being said, the seams are going to be pretty apparent because you know, this doesn't really hide the seams. Smart UV project doesn't hide the seams that well. If you want to re-import stuff, that's also pretty easy. All you need to do is just hit tab to go back to object mode, and let's go back to the layout mode here. A to make sure that everything's selected, file, export, again, OBJ, sorry, FBX, not OBJ. And here under arm, or sorry, not under, but here you do select arm, not arm animate, but arm, because you will be re-importing the skeletal mesh like that. Make sure that you don't bake animations. And that's it. So untick bake animation because we're baking out the form. Hit export. Does the thing. We go back into Unreal. Content drawer, and here you don't need to delete anything. You just go to your arm folder, right click on the skeletal mesh of the arm, right click that, re-import, And it's done. It's done, right? It just kind of updated it automatically. And now you can see that the texturing of this, while still being completely disgusting, is at least a little bit better. At least a little bit better. Let's make it nicer. So under, oh, there's no maps. Okay, that's nice. Do I really need to create a new material? That's fine. We can double click that. 8:59. Do I have time? Okay, ask questions, and while you ask questions, I'll create a material because we're out of time. So also 1 second, I'm gonna make sure that I have like a full-on list of what I want to show you and what I want to talk about. I just need to go through the list one by one to really make sure that I didn't skip over some sort of an important part about modeling. Because if you kind of miss one, then it kind of just adds up. One second. Yeah, okay, it's all okay. The last thing that I wrote down for myself is that I should actually show you the how to actually create a material in Unreal that wraps around the arms that we made. So I will be, yeah, I'll do that. So here, let's go back, close that. No, content drawer. Here we do have our kind of blue material that gets imported together with the arms. And I will just double click it. And this is basically node editor for material creation. To do this, I will be using textures. So instead of a color, which is param3D, I think, or param3, instead of that, I delete it. And I will use, I want to do Shift A. It's not Shift A, is it? It's right click. Something about texture sample. There we go. Which basically will ask me to give it a texture. We don't have a texture. What do? It's easy. We find a texture. To find the texture, you can either do Quixel. Quixel's pretty easy, pretty fun. I'm not signed in, so we don't do that. Instead, we do Texture Haven. These are like or Polyhaven these days. These are like the two main websites from where I get my assets as well as my textures and so on that are free. And here under Polyhaven, metal, do we have any? Do we do Resty? Resty is kind of, ooh, green. We do green. Hell yeah. Hell yeah, we do green. And here I'm just gonna download 2K textures. I don't care about them being, yeah, a zip file, and I don't care about them being like, or let's do 4K download. 19 megabytes is not that bad. We do need to unzip. I'm sorry for going fast. It's just I don't. Okay. Anyway, we for some reason only have the bump map and the displacement map. Of course, when I'm trying to go fast, it immediately, yeah, there we go. It immediately starts messing with me. So if you're downloading the textures and they're not downloading it properly, just click these three little lines here and choose what you want. So I will go simple. I'll just go diffuse. Don't really care about bump or displacement. I don't remember which one is for Unreal, so I'll just download both of them as JPEGs. Why not? Roughness, specular, I also need. Displacement, bump, AO, roughness, and metallic in one. No, I don't care about that. Okay, I download this again. This one was a mistake, so we delete that. Extract here. There we go. That's our textures. Then back in Unreal, let's close the. No, I don't want to save. For now, under content browser, I will in content I will create a new folder called textures. Textures. Enter. And here I'll just create, or I can just drag and drop in the full-on folder. Maybe I shouldn't. Let's just make a new folder called green metal. Okay. And here we just drag and drop in all of the. Okay, so so I made a boo-boo. Notice this. Notice the server right here. This was me just trying to go too fast. The server here. So every time when I try to drag something into that server, okay, there's always like a 50% chance that everything will crash. It's because it's like a launch security thing, and it didn't crash, so I'm happy. Anyway, we now have all of the textures imported here, and we have even the bump map. I don't care about the bump map. We have the normals, we have the displacement, specular, roughness, diffuse. That's great. Going back to ARM, opening up the material. Again, image, texture. No, not image, texture sample. Texture sample. Here, now I will be able to find green metal rust diffuse texture right here and drag the RGB into my base color, just like that. Easy. Now we have our texture right here. Then for, wait, is there anything that surface opaque? Yeah, that's fine. Then I will just copy, paste another texture sample. Here is going to be displacement, no, normals later. We can do roughness, and that goes into roughness. You can see like that. Then another one. Those of you who are familiar with creating, any kind of a node-based material, well, we'll see that this is, exactly the same as anything else. Specular. Specular right there. Okay, specular comes before roughness apparently in this version. And then normals, or sorry, not normals, texture sample. Trying to remember if normals needs separate treatment. I don't think it does. Ooh, that's disgusting. But sampler time normal, that seems like it's correct. So maybe it's gonna work. Normal. Does that seem like it's acting like it should? Feels like it's acting like it should. Yeah, that's fine. Okay, so that's good enough. But one thing is that we want to focus on the texture coordinates of the object to which we are applying the textures on top of. So we do need to grab the texture coordinates of the object like that. And then we will need to, yeah, we can change the tiling here, but I don't think we will need to. We can just grab the UVs and drag them in to all of this. Worst case scenario, we just multiply this, because you can always multiply, take the coordinates and you multiply them by param and then you're basically controlling the tiling that way. But I think we will stick to just using a master material as our main material, which is you shouldn't do, but we're out of time. So I save that. Okay, close that. Back in content browser. Let's just check. Yeah, that arm is looking fine, right? No stretching, no nothing. Like looks pretty. By the way, if the camera is all over the place, if it's too reactive, too fast, and so on, make sure to just decrease the camera speed to like 2 right here in the top right. And now it's much nicer, much calmer. Yeah, we have green arms. Okay, save that, close that. You'll notice that now if I press play, the arms are not green, and that's because the material of the arms is controlled through the third-person blueprint rather than the arm blueprint here. So that's the material of the asset, but we are overwriting it in the blueprints, third-person blueprint. And if I select arm here, viewport, you will see that, zoom in. Come on. There we go. You will see that here, materials, element 0, mannequin. No, diffuse 0. Perfect. Oh, I'm happy. Now it works. Okay. Save. Voila. There we go. We have green arms that for some reason look a little bit more out of place than our weird mannequin arms. Hey, it is what it is. You win some, you lose some. Okay, but that was about it in terms of the showcase. Was it? 1 second. Yes, that was it. The last thing that I have like full on stack of notes here.
Awesome stuff. Very in-depth. I like these arms. They're very fun.
Yeah, they're just flopping about. You can, if you were to build this up, you can have like proper behavior according to, you know, if you're climbing, if the like the hill on which you're climbing is steep enough, then you become a quadrupod, you know, with these arms that help you out, and they kind of stick to the ground and help you climb and so on. So you can go full on Death Stranding with this, honestly, but unfortunately, you know, 5 hours.
No, of course. Very cool. Does anyone have any more questions?
There was one that I kind of pushed to the end of this this webinar about the. Thanks, Gediminas. Yeah, welcome, welcome. What would you consider is the best route to learn Grasshopper for problem solving in this workflow? Depends on the level. Like on your level in terms of Grasshopper. If you're completely new to Grasshopper, I would like, it's like that joke where IT people spend, you know, a month automating a task that can be done in like an hour. So if you're kind of, maybe it doesn't matter if you're new to Grasshopper or not. I think it's the full-on rage of people who do this. So first of all is recognizing what you can do manually and what you can troubleshoot manually faster than what you would spend trying to automate with Grasshopper. I feel like that's a very important skill to have, and that students tend to lack that skill. At least my students might be different in different schools, but as a teacher in the uni, I tend to always rope back students from Grasshopper which is weird to say because I'm the Grasshopper guy in the university, but I tend to rope back the students from Grasshopper because once they start learning it, it's like they try to apply Grasshopper to everything. All of the troubleshooting and all of the kind of problem solving is done through Grasshopper. In terms of just simply being good enough so that you can troubleshoot things with Grasshopper, I think the best way to do it is to spend like first 3 months, 4 months going through tutorials, just mimic people. Find tutorials that you yourself want to kind of learn more about in terms of Grasshopper, and just kind of mimic. And then after you're kind of comfortable with the nodes and you don't get lost in them and so on, doing really small projects. For architects, I always say, yeah, just automate boring window creation, in Grasshopper. It's not flashy, it's not interesting, but you will learn, the basics of it, and you will kind of hammer in the basics, and you would be surprised how much is hidden in simple tasks and how much transfers to complex tasks from Grasshopper, within Grasshopper, sorry. So that's one thing. If you are an advanced user and you want to know, what's the best route to learn the precisely sub-D problem solving of Grasshopper, is to first understand topology. Try to understand how things in sub-D connect and how they behave. So when two, let me just quickly, oops. 1 second. Like just the sheer basis of it is, you have a box and you have this edge loop, and the closer two edges are to one another, the sharper that side is going to be, so you're controlling the smoothness through this. So if something looks like that, right, it's most likely that things are overlapping, and you first visually need to understand it to be able to then in Grasshopper say, oh, I probably have a lot of overlapping vertices that I need to somehow merge together to fix it. You first need to recognize that in the model. So I would say the first step for an advanced Grasshopper user is to understand how sub-D behaves when it breaks, and you can do that by just modeling in sub-D, just kind of practicing and going the full length with one of these projects will probably be more than enough.
I think that's like, with computational procedural things, like you have to have an understanding of the manual stuff that it's automating, which I feel like a lot of people skip. Like there's a lot of people that just getting into Grasshopper and never even play with Rhino, right? Like they just go right to Grasshopper or something like that, and like for instance, our master's is computational advanced design, but the whole first chapter is manual with Maya and ZBrush and learning polygonal modeling, because if you don't understand like topology, like how can you automate it,
Yeah, that's
way.
perfect.
And then another thing that I personally find useful is like, because my team at Wilderworld were fully using Houdini, but there's not much specific tutorials about Houdini in terms of like, let's say architecture or something like that. So what we found interesting was making the guys recreate Grasshopper tutorials, but with Houdini. Like they have to watch Grasshopper tutorials, but do the tutorial with Houdini. Like, and I feel like you can do the opposite too, where like, because then you have the problem, but you don't have like the answer that you can just copy directly, right? Like, I mean, computational just stuff, right? It's the same thing everywhere, right? Like
yeah,
whatever it
yeah.
is, just different software, different
Mhm.
tools. But you can watch a tutorial on something else and like try to do it with another software. So at least you have the problem, but you have to come up with the answer, I guess, you know. So
Yeah,
I
yeah.
find that to be like a useful way to do, because sometimes people are just like watching tutorials of the exact software they're doing, they just learn that thing and like not really understanding like how to get there like through a problem solving lens rather than just like a copying lens, you know.
Yeah, I see that a lot. I see that happening quite a lot. Is like very very what's the word, narrow professionals. Narrow is kind of a bad connotation behind it, but like a very specific professionals that are really good at Grasshopper. And
Mhm.
I've met quite a few of these. They usually pop up in academia. Uh,
Mhm.
to be honest, because it's pretty hard to be that. What would be a good other word for narrow? Well, I'll just use narrow. It's very hard to be that narrow in the working in the
Mhm.
field, in the industry, but in the academia, you know, if you have like 10 lectures of your own thing, it's, you know, the any university will facilitate you. So that tends to be, yeah, you're absolutely right. If you don't have the kind of understanding of um, the other aspects or other sides of the software, let's say, or of the geometry or of the behavior of the form, then you will be kind of stuck in this engineering loop, not engineering, but like engineering of scripts, I guess,
Yeah.
loop where it's engineering for engineering's sake, right?
Yeah.
Where it becomes this kind of a it's goalless. There's
Yeah.
no goal for it. And if you're creating a goal for yourself, for instance, re-engineering the Houdini, a Houdini script in Grasshopper, then suddenly you're forced to understand, first of all, how Houdini deals with it, and the person who did the script in Houdini, how he or she did it, and then kind of retracing those steps in Grasshopper and seeing, you know, the differences between the softwares, because while they are very similar in the core of them, they're very different in the wrapping, so to say, or the
Yeah.
outside portion.
Yeah, I mean they work in just completely different ways, but it's
Mm.
still like automation kind of in a way. But you know, for me, probably you too. I mean, when I was learning Grasshopper, there wasn't like these tons of tutorials around, you know,
No,
like
no.
um, but learning was better because I mean, for me and like a bunch of other people, like learning was just like solving people's problems on the forums. Like that was like
Mhm.
to me how I learned it, because then you're forced to like learn like the kind of thinking process rather than just like put this component, connect
Mhm.
this node, connect this node. You know, it's like you're you're forced to solve the problem rather than just copy the solution to the problem. You know, so
Yep.
that's one thing. And then the other thing is yeah, like understanding it like in a way that, you know, there's a big difference between like for instance Unreal Engine, right? Like you could, if you're just doing like a standalone thing, if you had this Unreal Engine and you wanted to just put like one building in here,
Mhm.
you can do it, you can do whatever you want. You can put whatever mesh you want in there, right? Could be any garbage dense mesh. But then when you go to the scale, for instance, like what we're doing where we need 110,000 buildings and it needs to be playable without lag at 80 frames per second and all this stuff, like then you really need to understand, like you can't just toss any mesh in there because,
Yeah.
you know, sure it works once, but how does that kind of crazy dense junk mesh work 110,000 different times in the same instant? You know, like, you know, so
Yeah.
understanding that there's limitations and the right way to do things, I think.
Mm. Yeah, because actually, like, just coming back to this, you're absolutely right in terms of the scale and understanding what works, what doesn't work, and just kind of being in control of multiple dimensions, I guess, of the
Mhm.
project is very important. For instance, with this arm here, we're eating up a full-on like character budget of
Yeah.
polygons with a single arm, simply
Yeah.
because the automatic quad remesher in Rhino, while it's a powerful tool, it's not good enough. You would need
Mhm.
to do this manually. Even
Mhm.
worse thing that you could do is in Rhino, just you select this. Sorry, mesh. God damn it, mesh. There we go. Um, Simple controls. Let's go for simple. And you just say, yeah, fewer polygons. Sure, hit OK. And, you get this kind of a mesh. It would work. It wouldn't work for soft body like characters because they would bend really, really weirdly. But it
Yeah.
would work for this kind of a robot character. But the problem with it is, first of all, texturing would be just hell. Second of
Yeah.
all, the behavior of, like, if you were to use complex collisions which actually follow the form of the body, that would
Mhm.
freak the fuck out, and then so on. So you would have so many so many issues that are underlying. So while you're saving time by just typing in mesh, and you're saving time in terms of modeling, maybe because you don't know modeling, maybe some other reason you don't have the time, you would pay the price then later
Yeah.
once you need to texture it, or once you need to actually have a playable arm that actually doesn't intersect with everything as it's flying around, right? Which has
Yeah.
proper properties. So quad
It's just,
remeshing is great, but do
yeah.
the manual one.
Yeah. I mean, in Houdini, we're doing everything like procedurally and it
Mhm,
works out, but we rely a lot on, because with Houdini, we're kind of attached the texture baking
mhm,
into the method. So it's mostly like Unreal Engine tricks with maps, and like the mesh underneath actually
mhm.
looks like nothing almost compared to when you have like normal maps and all these things.
Oh, really?
Um,
Okay. Because the stuff that I've seen on Instagram from you guys, I mean, you can see that it's generated, but it felt very clean.
oh yeah,
Like it,
it's very clean, but it's very super low, super low res. The actual mesh is like,
and then baked in normal maps, huh?
yeah, those complex characters are like 10K polys, something like
Jesus.
that,
Okay.
10, 16K polys. But there's maps automated from like super high poly versions, and then
Mhm.
we use things like normal maps, parallax maps, these kind of maps
Mhm.
that give you a lot of depth and detail.
Are
Um,
you using 8K maps or 4K, or is it like a UDIMs and then just varying sizes of maps?
we're using like 4K now,
4K. Okay.
yeah. But the mesh underneath is so funny. I mean, it looks like a standard human character by the time it's like optimized. It's like blobby. Um,
But
but yeah,
that's pretty cool. That's
yeah,
really cool.
yeah. But it's only in that case, it's only possible because it's all attached in the same system.
Hmm,
Like
hmm, hmm,
everything's in the network, and the nodes, everything's together. Because we're not
hmm.
we don't want to make these like 10,000 character collections manually. We don't want to touch anything. But I was like, that's just one thing I want to mention while we're on this topic. You like, metaverse and games, they're like very big right now, but like, and you see all around like people make this building or they make a character, metaverse, but I'm like,
Mm.
okay, now show me it's 100,000 times in Unreal Engine and show me what is your frame rate. you know
Yeah,
Put
and
that character 100,000 times in Unreal and have them all running around and show me what's the frame rate.
actually I can't show it now because it would take too long to load in. But the game that I made, that the game that I shown,
Yeah.
that is, I, I I think Unreal Engine 5 enables you to do that kind of stuff.
Yeah.
While in Unreal Engine 4, that would have been a bitch to deal with. The fact that you can kind of remesh in real time, so to say, the
The
nanite mesh
nanite, yeah.
is, in my opinion, like amazing. And then at that point, it just becomes what you guys are doing, being smart about your assets and the library of
Mm.
your assets and how do you generate them.
Yeah.
So the game that I showed at the start, that's like 13 assets in total. The whole map is made out of, the marching cubes,
Yeah,
instances.
instances,
So
exactly.
it's 13 assets. For you, it's different because you will have like so many dynamic characters that are all unique.
But that's the way to think about it, like the marching cubes, like instance
Hmm.
pieces, like in how many ways can you mix these pieces that they look not like you just repeated,
Yeah.
right? So that's kind of like the trick, right?
Yeah,
That's
it's always it has been the trick ever since
yeah.
Mario.
Yeah, exactly. Right. Well, I don't want to go too far off topic, but that was a really, really nice webinar. As I mentioned
I'm
in the
happy.
beginning, I always like how in depth you get into things, and I kind of like your way of doing. It's like not afraid to show mistakes as well, which is good because we should learn from.
Well, sometimes we don't have a choice.
Yeah, exactly. Yeah, some of the best webinars always have to me like these errors and mistakes and then how you fix them. I think people learn a lot from that.
Okay, yeah. Well, it's maybe later. After the webinar is done, then I will go back and then see that. Oh yeah, that was a good thing that I struggled with the quad remesher for half an hour, just going, oh, this
Yeah.
is because of the new version. This is because of the new version.
Yeah, exactly. Well, is there any more questions? Anyone? Not, we can end it. And of course, afterwards, this recording as usual will be sent through email. If you
I think like I saved all of the files into one folder, so I will
Oh yeah, if you can
probably
send me the link, then
give
I
you
can.
the full folder, and then you can
Yeah, I can
distribute it to the
distribute it.
students.
Yeah, of course. All right. Well, thank you. And you
That
got some
was
hearts and clappy hands going on. And
yeah, that was a pleasure,
yeah,
to do this. Um,
I
yeah,
hope for our next one.
thanks everyone. I'm tired.
Yeah. Yeah.
Okay. Yeah, thanks everyone for tuning in. I'll
See
see
ya.
y'all.
Bye.
Bye.